All right, I think today we will start on this topic on the bar model. All right, now you can take notes anything you want, but I will give a handout later on at the end of the session there. You can, but if anything you like, you're free to use your phone to take a snapshot of the slide. It's fine with me. I got no problem with that, okay? And by the way, my workshop is very informal. You're free to ask me questions, raise your hand or anything, you know. So I want to interact with you people and see how things are going. I want you to learn something. That's important. Now, I basically break down into these 3 topics for this workshop. The first one, of course, is an introduction. I talk about what is bar model and why we teach bar model, okay? So these are the things here. And of course, now the second part is the main bulk. We're talking about bar model method. Now, there are quite a few methods there, and you will pick up all those methods that you can use it. And last but not least, the question is that, okay, you have learned bar model, you know what it is, how to teach. That's important, because at the end, you know, the students are supposed to learn how to use bar model to do problem solving. So that's pretty well, you know, cover up in this particular workshop here. Now let me talk about the introduction. By the way, you know bar model, where does it come from? I mean, you heard about bar model? It's from Singapore, right? Yeah, Singapore bar model, okay. So, but I know that in Malaysia, you don't use a bar model. That's why I do know that. Singapore has been using the bar model, and it has propagated to many other countries already. I've been to many countries to teach the teachers about bar model, because they want to see, you know, because Singapore, I think the math in the PISA there is quite high. So either it's a number 1 or number 2. So they wonder how come the Singapore kids can score such a high score, you know, in all those international competition there. And so one of the things there, by the way, when they're young, bar model is one of the tricks that they've been using. Okay, so start with the introduction. Now, what is bar model? The very first question, very simple one. Well, first of all, I said that it's a visual tool that the kids can see. That's important, okay? Why? Because I'm talking about word problems. Now, the whole idea in mathematics, I'm sure you agree with me, perhaps the most challenging part in learning mathematics are solving what? Word problems. Am I right? Just whether it's in the grade 1 all the way to grade 6, they face the same problem there. So, now this whole idea why we need the bar model, which is a visual tool to transform word problem into a pictorial representation. They see a picture. Okay, so this whole idea there. Now, since I use the bar model, you expect it must look like a bar. This is like a bar here, right? I'm not a gold bar fan. Now it's a bar. This is a particular box there. That's a bar, okay? Now, that little bar that you see, it stands for what? Either it's a known quantity or it's an unknown quantity. So depending on what you want to label it, fair enough. All right? Now, bar model is most suited for certain types of word problems. Not all, by the way. I must say that some word problems you don't use a bar model, okay? Use other types of strategies. But in this case, we are using a bar model to solve what kind of word problems? Whole numbers, fractions, percentage, ratio, and decimal numbers. And by the way, all these numbers pretty well dominate the whole primary math curriculum. Am I right? Okay, so this whole idea why we talk about that, okay? Now, later on, you know, when they go to the secondary, grade 7 onwards, they use algebra. Then, in that case, bar model enables students to solve arithmetic and algebraic word problems. We will move it from bar model to algebra later on then. But today, I won't be able to cover that. Usually, I will do that only for the grade 7 teachers, because once the grade 6 come up, they use a bar model. I must help the teacher to understand how you can help them to transform from bar model to algebra. But for today, we stick purely into bar model first. No algebra, just to let you know. All right, so that's pretty well, you know, very brief introduction about bar model. Now, just to give you a bit of history of bar model, when it gets started. It's actually in the 1980s. What happened is that Singapore at that time, by the way, at that time, Singapore, the students' math is also quite low, to be honest with you. By the way, I'm a Malaysian, I'm from Penang. Okay, and in the good old days, actually the standard in Malaysia and Singapore is about the same though, to be very honest. Yeah, so, so Singapore is also the same at that point in time, students are not doing well. So the Ministry of Education said, how can we improve the students' mathematics proficiency here? So because of that, they sent a team to all over the country to learn what are the things that we can learn from other people to help our kids in learning mathematics. So they went to many countries, by the way, to make a long story short. At the end, they get all the idea comes back. Then they have created this idea about bar model. And what happens is they find that once the kids see the picture, things are a lot easier to solve. So they have this, in the 80s, they come up with this bar model. And they were the first roll out to all the schools in Singapore there. Now, one of the things you must understand, when the first roll out, it's the first time. Both teachers and students see it for the very first time. And what happened to the parents? Parents haven't seen it because when they learned math in the good old days when they were young, it's the old method, am I right? So, and one thing the ministry make an announcement telling the parents, don't teach your kids mathematics, leave it in the hand of our teachers. Because the kids will get very confused. The teacher teaches one way, and then the mother will tell them another way. So please don't confuse the kids. So that's the reason why when it first came out. So that's why if you go to Singapore, many of the parents, even today, is in their 40s or whatever, they know nothing about bar model because they come from the old school. Okay, so that's what happened during those times there. But of course, by now, most of the people are familiar with bar model because they've been known, loud and clear, and it's gone worldwide. So that's what bar model is all about. Now, why we teach bar model? Not only what it is, why? The whole issue is about our human brain. Why? Because our brain is good with pictures. We can process visual information a lot faster, more effectively, okay, than text reading, words, numbers, orders. Why? Words, numbers are symbols. You see, when kids learn, when they're young, what they learn, they don't learn words. Actually, the kids know what's the chair, what's the table, when they're crawling on the floor, right? They know what's the chair, but except they don't know how to say that. They can say a chair or table, but they had a concept of a chair and a table. And they see the chair got 4 legs. They know how to call that four legs. The kids know that I can sit on it and it will not fall. So already the kids have a concept of a chair. So what happens when they go to school? The teacher will tell them, okay, this object is called a chair. It's only a label stick to that object which they are very familiar with. So that is why words, numbers are symbols. It's hard to understand. They're abstract, by the way. Okay, but pictures, it's easy. They're easier to understand. So that's why we teach bar model. Now, if I give this word, you know what it means? You know what it means? Wow, it's called a CCG, by the way. Hard to pronounce it, okay? Literally, there's no vowels there. But what is it, by the way? But if I give a picture, oh, you see all the planets all in a straight line. Now that is the meaning of it. That is it. This is only a label for a picture, am I right? So that's why when we see this, when we see a picture like this, when we have labeled associated to it, then we can answer, oh, now I know what it means, because we are recalling how it looks like. The picture makes a difference. So that's the reason why, picture is a good way to learn mathematics. Now, we go a bit into our human brain. I say that human brain processes visual data better than textual data. Why so? No, sorry. Human brain processes images 60,000 times faster than text. In other words, if you give the kids words, a paragraph or whatever it is, you get a picture, he can learn better from a picture than from the words, to be honest with you. Am I right? Actually, we adults also do the same thing. When you go to another place to visit and take lots of photos, am I right? When you come back, you want to show your family or your relatives, your friends. Do you tell them how nice it is, how beautiful it is? No, picture speaks for itself. See, that's the whole idea. Picture can communicate a lot better than what we can say, in other words. So that's why I say our human brain processes images 60,000 times faster than text. Now, about the time it takes 50 milliseconds for our brain to form the first impression. Look at it, how fast. Okay, so that's the whole idea that we're talking about. 90% of information transmitted to our brain is visual. That's why you see that in the lower grades, grade 1, or even the grade 2, with lots of pictures, am I right? Than words. So that's the whole idea, you know, because pictures can transmit information a lot faster and it's easier for the kids to understand. Talking our hard disk, well, our hard disk in our brain, okay, our disk capacity. We can hold 25 million gigabytes, a lot, by the way. This is our brain. You got 25 gigabytes in your body up there, okay? It's about 5 times as much as an encyclopedia. My goodness, in your brain you can store 5 encyclopedias though. It's very big storage, am I right? The trouble is that we don't know how to retrieve it. That's where the trouble is, am I right? We can store so much data, but we cannot retrieve some of the information, you know, because, oh, I forgot, you know, how it looks like, or, you know, what it is. So that's basically what it is. Nine. But talk about retention in the brain there. Brain can retain 95% of information from the visual data and only 10% from the texts. Now you understand. As a teacher, you tell them in 1,000 words, it's not 10%. It's not much. You get a picture, you say, oh, well, now I see. So that's the reason why. And in Singapore, I think there's 1 year, the Singapore Prime Minister, during the National Day speech, and he made a statement there, you heard of it, teach less and learn more. So how to teach less? Now, what are they talking about? Teach less and learn more. What he meant actually, you don't have to spend so much time keep talking to the kids. The kids can learn on their own. Okay? You can teach them, yes, but give them time to learn on their own. Hands-on pictures, whatever that is, they can learn better. It saves your breath, saves your time, keep telling them over and over. Because for one good information, if you give all the information to the kids there, in the text form, they only retain about 10% of what you're telling them. Okay? So we rather let them retain 95% from pictures. Now, but during the learning process, our brain actually receives both textual data and visual data together. Fair enough. We need both. I'm not saying that textual data is no good. No, we need that, by the way. But it's just that we need the visual information to mix together, interact together to make the learning more effective. That's the whole idea, okay? So visual aids help to conceptualize and explore ideas to enhance understanding. Like, we can use a diagram, chart, or model, or anything. But what with the textual information? It provides structure and precision, very precise. When you go about text, it's very precise. In mathematics, very precise. It spells exactly what it means. Okay, so we need textual information. So therefore, we need both visual and textual information to complement each other. All right, so that's the whole idea. Now, I think for primary kids, many a time they have a language problem. It can be an obstacle in the learning. Am I right? Especially those that come from the Chinese school and they first come into Eduseeds, they say, in English, and they get stuck. Fair enough, and I don't blame them, you know. So it can be an obstacle here. Now, this is what, for those students who have what, low language proficiency in English, for example, they have this problem here, all right? But even those have no language problem, can they solve problems there? Yes and no. Some say, yes, I can do. Some say, I still cannot do. It reminds me one time I was in Jakarta. I was training a group of teachers in Jakarta. Why? Because at that time, the Indonesian government announced that they want both math and science to be taught in English. Now, don't forget, all this while, they've been teaching both math and science in Bahasa Indonesia. No English. And suddenly, the government said that let's use English as a medium for instruction for math and science. So they said, how to teach? So I was there, they sent me there, and I was teaching them. Anyway, it was quite fun. Then I told them one thing. They said that they have two problems. The first problem is a language problem. When the kids read the word problem there in English, you don't understand. To be quite honest, they see it for the very first time. Even if they understand it, the second problem, math problem. Now, I asked them a question. If they don't understand the word problem in English, suppose you translate into Bahasa Indonesia for the kids. Now they understand all the words there because it's in their own language. Can they solve? They say, no. Why? No, that's a math problem. Right? You take away the language problem, they face a math problem. How to start? So now in that case, they got two problems there, language and the math problem. So that's still a possibility. Even those without the language problem there, they still face a problem in what? Mathematics. So that's the whole idea. All right, now I will address these two problems here in some of my later slides. I will show you how you can do it, all right? Yeah, so therefore, as I said before, word problems has been a challenge to many students there, and I think bar model helps to remove both the language obstacle as well as the math problem together. We use a bar model just to do it. So this whole idea about bar model. All right, I think I've given you enough reason why. You believe it? I'm not. Have you been using bar model in your teaching? Yes or no? How good is a bar model? Are you very good with it? Still struggling? It's okay, don't worry. I don't blame you for struggling. And I know what's the problem, why you struggle, okay? Because you know why? I face the same problem in the good old days. Yes, there's some difficulty when you first learn it. Okay, so today we'll go a bit slower. Don't worry about it. All right. Now let's come to the main part of it. This is the bar model we're talking about now, okay? The first is the introduction. Now, actually in grade 1, we don't really introduce a bar model. We introduce what we call the picture model. We give pictures like this. They can see very well. You get pictures, or you can give them an actual object. You can give them the actual pears and oranges or anything that you want. All right, for example, you say that Elaine bought 5 pears and Ken bought 3 pears. How many pears did they have all together? So either they had the actual pears in their own hand, they can count how many are there, or they can use the counters, the round counters, to present all those are pairs here and do the counting. It's the same thing. So in grade 1, usually they will see this kind of a thing here. All right, either they will draw a circle or they will do all those things there. And now, eventually, we make them to draw pictures like these are boxes. These are little squares here. So what they learn in grade 1, usually every little square stands for 1. So when they see this, it's a 1 pair, 1 pair, 1 pair. So that's what they've been doing. That's for the grade 1. So if you see the grade 1, that's what they will see. Every little box there, is only stand for 1. One person, 1 pear, 1 apple, or one for anything. Okay, so that's what they've been doing. But as they go to grade 2 onwards, now the bar can be longer, can be shorter. So they will learn that a longer bar represents what? Greater quantity. More quantity, I will have a longer bar. A shorter one, it means what? Smaller quantity. So they read the size. It's very visual, right? Longer means more, or shorter means less. They can see that very well. So this whole idea, you see, you take this more and less using the length of the bar to represent. Now, when two objects or when two quantities are the same, what do? We draw them same length. You can see that, same length. So, okay, if this apples and this pears here, same number of pears and apples. If here's the 5 apples, here's the 5 pears, they can see that very well. So we'll draw at the same length, means equal quantity. So that's how the kids will learn to draw the bar model. Now, these bars, as I said, can represent what? Either known quantities or unknown quantities. Okay, so depending on what you want. Now, let's look at this example here. Ken is 24 years old, and Alex is 6 years younger than Kim. How do you draw this bar model? Okay, who is older? You say, okay, kids say, Kim is what? Older, Alex is younger. They will say that. Okay, how do you draw the bar model? Well, since it's older, the bar is longer. The younger one is shorter bar. So longer bar, they'll put a label, okay, this is Kim, this is Alex, okay? They will draw a longer bar, a shorter bar. And then it's a 6 years younger, the difference is here. So that's how they will draw it. So when you teach the kids to draw a bar model, step by step, give them something like that, you see, I didn't even ask any question, I just teach you how to show the kids to draw the bar model first. Don't talk about solving problem yet. Just learn how to draw it, that's important. Okay, to draw the correct bar model. Now, by the way, if you have a question, just raise your hand. So far, so good. Okay, I'm not too fast. Huh? Okay, that's good. Now, there are 3 types of bar models. We have the part-whole model, comparison model, and before-after model. And today I will cover all the 3. It will go through all the grades, okay? From grade 2 to grade 6, all these 3. Let me start with the first one, the part-whole model. Part-whole model means what? That means you have a whole, an object, okay, whatever that is. Maybe, you have a box of balls whatsoever there. So one box of balls, these are the whole. Parts are what? Inside there could be different colors. Red balls, white balls, yellow balls, okay? So each one is a part of the whole. So this is mean a part whole. So in other words, you either have what? 2 or more parts to make up a whole. That's it. And usually in problem solving, students can be asked to what? To find a part if it's unknown, right? The part can represent an unknown or unknown quantity, depending on what is needed. And same for the whole. It can be a known whole or it's an unknown whole. So depending on what you're talking about. And therefore, so I'm supposed to what? Solve for the unknown quantities. Whether it's a part, whether it's a whole. These are typical kind of word problems for part-whole model. Now, take a look at this one here. Out of 140 pebbles in a box, 87 of them are white pebbles, and the rest of them are blue pebbles. How many blue pebbles are in the box? Now the question, look at it. What do they want? You want to find out what? Is it a whole? No. It's a part. The whole is already known, right? How many there? 140. So I know the whole already. What's there to find? Okay? And also tell me something about the white. They will tell you that how many white pebbles are there. So therefore, you only need to find the blue pebbles. That's it. So the kids can just draw a simple bar model, something like this. Okay? The whole, a long bar, 140 pebbles. The white, 87. And the blue, sorry, I don't know what that is. So very simple bar model, and once they draw it, the solution is easy already. They can say, oh, I know, teacher, it's subtraction. I simply take away, 87 from 140, I get my answer. That's how they do it. So I think it's good to train the kids when they're young to draw some bar model. Now, of course, I know that sometimes in the class, you can rest my Alex and say, teacher, I can solve without the bar model. Yes, they can do it. Because that's a very simple question. Some of the kids can literally do it. And I don't blame them. I said, fine, you can do it without the bar model. But the trouble is that if they may come across another problem which they cannot solve, And okay, you know, so can you draw a bar model? I don't know how to bar model. They never practice drawing the bar model. So it's good to practice drawing the bar model. Whether or not they will need it, it doesn't matter. Okay, but they will learn to draw a bar model first. So when it comes to some difficult questions there, they will learn, oh, I know how to draw the bar model. So this is the whole idea. Now, I'll give you another one. A supermarket packs 336 peaches into small cartons. Each carton has 8 peaches. How many cartons are required to pack the peaches? Now, how to draw this bar model? I'm sure all of you know how to solve the problem there. That's quite easy. All right? It's a straightforward division problem here. Okay, by the way, I think that's what I will call to you, teachers. I think all these questions that you see is very easy to all of us. The problem is not whether we can solve it. The question is whether kids can do it. That is a challenge to the teachers. Not so much I know, but how much can they do? So sometimes as a teacher, I also make this statement here. We must learn to see through the eyes of the children, not our own eyes. To us, too obvious. To the kids, simply not obvious. So bear that in mind, how they see it. All right. Now, okay, so therefore they must learn how to draw the bar model, something like this. Okay, how to represent it? They say, how many cartons are required to pack the peaches? Each carton, I can put in 8 peaches there. Now, the way to draw it, since I don't know how many, I will draw it this way. I don't know how many, but at the end, all the peaches must go into the boxes, no matter what. So, I know each one is 8, okay? So I know the total number, after I pack all into the cartons there, it will be 336. How many cartons? See, that's how they will do it. So that's how they draw the bar model. Quite straightforward. You can see the part whole, right? So the whole is a 336, the part is a 8. So that's how they will see it. Clear so far? I think in drawing this. Now, so they work it out. Then you know there's a straightforward division. By the way, talking about division, no. Students, do they have difficulty with the simple arithmetic? Addition, subtraction, multiplication, and division? Okay. There will be another workshop, I think, next month on the problem-solving strategies. That's where I will cover about difficulties faced by students in also doing those very basic arithmetic. How to add, how to subtract, how to multiply, how to divide. I think that's quite important, okay? And some of them can't remember the multiplication table. 6 times 7, 6 times 7, don't know what's that. Like a stack. So these are the whole idea. It's quite common, we see among the kids. So how to help them in all those areas there? These are not really big problems to solve. These are the important skills they're supposed to have. Okay, but today, sorry, I don't have time to cover all those things there. There'll be until March. There'll be another one. Watch out! It's called problem-solving strategies. For primary mathematics. So I would cover that. But today, I assume that's okay. We're going to look at solving the word problem using the bar model. Now, I'm talking about fractions now. Fraction, perhaps, I think, one of the more difficult concepts for students. At first, they learn whole numbers. Am I right? In primary 1, they learn whole numbers. Primary 2, we started to introduce fractions. They learn about half. They learn about a quarter, a third, and all the things there. They will have all the symbols. Finally, they begin to see a number, in 2 stories. I see something like this, not a 1, but got a bar in between and a 2 below. So they begin to see something, for the first time, they see things of these sorts, okay? 2 over 5, for example. And we call this a fraction. What is this? Now, when you teach a fraction, the whole thing comes about what? Part whole again. Fraction means that there must be a whole. You don't have fraction out of nothing. A fraction means it's a part of something. Am I right? A part of something. Yeah. So, but the only thing is, a part of something, so let's say I talk about 1 over 4. So there must be a whole, am I right? 1 over 4, so this is a part, fair enough. And there must be a whole. What's the whole? 1. 1 whole, am I right? 1 is a whole, all right? So that means the whole is divided into 4 parts, number 1. Not only that, the 4 parts must be all equal, same. Well, power can be not equal, though. Am I right? It can be more or less to make a whole possible. But in this case, all the 4 parts must be equal. So we draw it now. When we draw about, you make sure they draw about the same size. And by the way, okay, just share with you, we use the word units. Bear it in mind for the word instead of the parts. We say 4 parts, we say units. How many units? So therefore, a whole in this case make up 4 units. Each unit is called a quarter, or 1 over 4, whatever they call that. So they will get used to the terminology here. Say, a whole consists of 4 equal units or 4 equal parts, the same thing. That's one of the things they will learn. All right? Now, so I said, all the units of the whole have the same size. That's important. Now, look at the problem here now. In a concert, 2/5 of the attendees are girls and the rest are boys. If there are 51 boys, how many attendees are in the concert? You look at this one here. Is it a part whole question? How many are attended in the concert? Am I right? I want the whole. Yes. So I only know that what? 2/5 of them are girls. But the boys, the boys I know, 51 boys are there. In total, how many? In the concerts, in other words. So how to draw the part whole for this one here? Two-fifths means that what? A whole is divided into 5 parts or 5 units. 5 equal parts or 5 units, we call that. And they can, by the way, I mean, my colors just to make it a lot more obvious, but they can just shade it, or if you don't shade it, what is important, they will label it. That's important, label it. That means 2/5 means what? There'll be 2 units out of 5, right? These are the girls, so the rest must be boys. So that's how they will do it. So in other words, now what happened? They take the word problem, they transform into a picture, which we call a bar model. And from here, they say, oh teacher, I think I know how to solve it. It's very obvious, right? I see the only part which I have the information is what? The boys. So I need to find out how many are there, right? One unit is how many? So I know 3 units, 51. 1 unit, 51 divided by 3 is 17. So I need to find what? How many attendees in the concert now? I put a question mark here. That's important. I know where I'm supposed to find my answers. I want the whole. So I put down there, 5 units, 17 times 5, 85. And that's it. Is it easy to solve the problem there? By the way, at what grade level, this question? Who can tell me? Grade 3? Grade 4? Grade 2? Fraction? Grade 2, yeah, the fraction. But grade 3, you don't learn the concept of fraction? No. You don't have the concept? No. Grade 3 at least. At least grade 3. Okay, yes. So, okay, go about grade 3, they'll solve this kind of problem. So therefore, you can see that a picture is not clearer for them to understand. Am I to say that if I hide a picture, see the words there? Kids, I don't know where to start. I don't know where to start. So, I mean, that's the whole idea. Now, about ratio. Now, ratio, I think, is taught in grade 5 onwards. I think it's grade 5, not mistaken. 5, 6, all about ratio. Okay? Now, look at this question here. Sharon and Tim share a bag of rice by mass. That means how heavy it is. In the ratio 2 to 3. So in the mind there's a bag of rice. I want to divide it into how many parts? 5 parts. Am I right? 2 portions is for Sharon, 3 portions is for Tim. So it's easy. I will just draw it now. Again, ratio, when you see this, all the sides must be equal. Again, am I right? You can see that all the sides are equal. Equal size here, sorry. Equal size here, am I right? Equal size here. And I know that, the ratio is 2 to 3. They share everything, all the rice in the bag. That's it. So, by the way, ratio and fraction are close to each other. There are 3 concepts in mathematics. I call them the 3 musketeers. Fraction, percentage, ratio. Kids must learn all these 3 altogether, the way I see. Even though they're in different grade, yes. But at the end of the day, they must learn how to tie them all together. They're actually inseparable, to be honest with you. Okay? I will have a separate workshop, again, only on these 3 concepts. Fraction, percentage, and ratio. How to combine all together. Because sometimes in a word problem there, you have ratio, you have percentage, you got everything inside there, to be quite honest. So kids say, I see percentage, I see fraction, or I see ratio in the same problem there. How to handle it? So that's the whole issue, okay? But that one, again, will be in a separate workshop. So that's how you would do it when it comes to ratio. All the units are equal in this case. Now, look at this question. The red and the white paints are mixed in the ratio of 3 to 4. The total amount of mixture is 18.2 liters. Oh, here I got decimal numbers already here, by the way. Watch out. 18.2. How many liters of white paint are in the mixture? Now, here, this question, I must find the part or the whole. The whole. No? I know the whole already, right? What's the whole? Total amount of the mixture is what? 18.2 liters. I know the quantity already. So therefore, the question asks me what? How many liters of white paint in the mixture is a part? So I must find what's the quantity of the white paint in the mixture. How to draw this one here? Same. You see that? Quite straightforward. That's what you've seen earlier. The red paint, the white paint all mixed together. Total is what? 18.2 liters. That's how they would do it. By the way, when you draw the bar model, what's important is that they must learn how to label it correctly. That's important. Now, I don't care whether they put the label below or above or the number below. It's the same. It doesn't matter. Okay? They want to put the red paint on this side, the white paint on this side. Fine with me also. It doesn't really matter. As long as the picture happens to solve a problem, that's what matters. Okay, it's a picture that to help to solve a problem. That's what. So how they will label it, it doesn't really matter. But of course, don't make it too messy. Then they themselves don't understand what they are doing then. So you can see that. I can see altogether how many units. Okay, 7 units, right? Make up the whole. So I start from the whole. Since I know the whole already. You see, in other words, in solving word problem, you must start something you can find. Obviously, you don't start with a white paint because it's unknown. How to start with the unknown? It's very hard to start with the unknown. You start with the known. I know total number is what? 18.2 liters. So I start from the whole. And this whole has 7 units. So 7 units is equal to 18.2. I will find 1 unit. Now, in practice, I always let the student handle it this way. 7 units, how much? 1 unit, how much? That 4 units, how much? This method, we call it the unitary method. The reason why I named it, because I already forced to find the 1 unit. Now at the higher level, sometimes they can skip this one here. They can go from 7 to 4. They can do that. Quite honestly speaking, because they can use a fraction to do it. All right, because you can see that they can use a fraction to do it. I can do this one, right? 18.2 times what? But I think when they first learn, it's good to go then step by step. There is also one reason why I read it this way. Because I think in grade 4 onwards or 5, they learn a concept called the it's all about rates. I'm using unitary method to slowly introduce this concept here. That's the reason why I purposely go to say, well, it's very obvious. It's very obvious. Yes, I know that. Because rate is what? Per unit something, right? Per unit something, yeah. So, similar about per second, per minute, per hour. So for every 1 hour, every 1 minute, that's why I use this way to talk about the rates and speed. Except I don't use the word rates and speed when I talk about this one. I call it unitary method, that's all. You see that? So, okay. So far, so good? Oh, good. Anyway, so far, I think this morning, you are quite all right. Okay, another one. I'll give you a few more questions here. Let's see what it is. Ravi gave 1/3 of his weekly pay to his mother. He then spent 2/5 of the remaining amount on grocery and was left with $96. How much was his weekly pay? Oh, this is a bit complicated, with all the fractions here. Now, one of the things in learning fraction, the kids better in mind. When they see a fraction or even a percentage, also, where is my whole? That is important. Where is my whole? I always ask you, why? You look at this question. Actually, here I got two fractions, right? 1/3 and 2/5. But the problem is, these two fractions have different wholes. That is important, not the same whole. This 1/3 refers to what's the whole? The weekly pay. This fraction refers to what? Where's the whole? It's what that remains. Different wholes. That's one important thing when kids handle this kind of question. They are not all the same, the wholes. It's the same when I give you this kind of a thing here. Let me ask you. A 1/3 right there. Of course, the kids can work it out quite easily. It's what? 5/6, am I right? Now, let me ask you this question here. Look at these three fractions. 1/2, 1/3, and 5/6. Are they the same whole or different wholes? You ask the question. That is important. Even though we don't put any units here. Okay? The concept is all these fractions you see in this addition here must refer to the same whole. What if I tell you, I have half of an apple, I add to 1/3 of an orange. I got 5/6, what? Apple, orange? Cannot. It's the same thing, am I right? So there are times the wholes are the same, but there are times when the wholes are not the same. That is where it makes fraction a bit tricky for kids to learn. But that's important. That's exactly where they get confused in learning fractions. Okay, so never mind, I'll talk about this another time. I'll just show you that fraction is the worst thing in mathematics for the kids to learn because the whole can be different. So in this case, I can see that this 1/3 and 2/5 refer to two different wholes. And of course, I only know one known quantity, what's that? This amount, right? That's the only thing I know. At the end, he spent all the money, he's left with what? That's the only thing I know. So how to draw this bar model? I'll show you how to draw. Okay, so to see how to draw this bar model here, I'll show you how it is like. First of all, now let's step by step. He said, Ravi gave 1/3 of his weekly pay to his mother. So this long bar here must be weekly pay, am I right? It's a whole. I divide into 3 parts. This 1/3 go to the mother. So this part is what that remains, put it this way. Now, he said, then he spent 2/5 of the remaining amount on grocery. Wait, how do you divide into 5 parts? It's hard, right? It's because you know where it goes. So usually to make life easy for the students there, I do what I call the drop-down bar. I drop down. I can't cut this one here, but I drop it down, the whole bar, I cut into 5 parts. That's all easier to see. You see, the whole idea is to make the visual part easier to understand. If you try to cut it into 5 parts there, after a while they get very confused already. Here's the 2 parts, here 5 parts, they cannot relate. So I press, okay, draw this bar here, same size by the way, I'll divide into 5 parts. And once I do that, now I start reading it. He spent 2/5 of the remaining amount. So this is the remaining amount here, right? On what? Grocery. 2 units for grocery. And he was left with what? $96. Oh, this $96. Can you see that this picture literally come from the whole question there? You literally transform the words into a picture, am I right? So the kids learn how to draw. That's important. They learn how to draw. So once they see this picture, life is a lot easier to understand. So what they do, okay, now I can see it. 3 units, 96. So of course, 1 unit, again, they say, I'll do 3 units, 1 unit, 5 units here. So work it out. Now, don't forget, these 3 units, 1 unit, 5 units, refer to this shorter bar here. This is my whole. This is my whole for this calculation. You follow me? This is my whole for this calculation. This 1 unit is not this 1 unit here. It's a different, as I said, there are 2 different wholes. Am I right? So therefore, after I've done that, I found that 5 units, 160, yes. What does that mean? Now I must go back, I must go from here back here. I have to find this weekly pay, right? So therefore, what I would do is, I will have another here. I can see that here now. From here, I'll go back there. Okay, so from here I see that 5 units is 160. This shorter bar here, shorter hole here. I go back to this longer bar here. 2 units is 160 because they're the same. So I say 2 units, 160. 1 unit, 80. But I want to find the weekly pay, right? This 3 here. So 3 units, 80 times 3. Oh, my final answer. That's how they do it. This is a grade what? 5 or 6? You think the picture is easier for them to solve the problem there? That's the whole idea. Okay. Okay, by the way, anything, are you confused or are you okay with me? What say you? Is it too much? Any feedback, come on, let me know. Are you okay? Okay. What grade are you teaching? 2. Grade 2. Okay, never mind. It is good to learn about higher level there. Yeah. You see? Anybody teaching the grade 4, 5, 6? You do? Anyone? No? Okay. Yeah. By the way, in grade 4, 5, 6, what are the typical topics that they've been learning? Can you share with me? What topic they define difficulty? The kids. Oh, easy? Algebra. Actually, you know what? In primary school, we don't emphasize so much on algebra. There's only 1 module in grade 6. It's on algebra. And the algebra there is very, very elementary, to be honest with you. Okay? They will learn the X, Y, Z to only represent an unknown quantity. That's all it does. And they're supposed to write algebraic expressions, and then they will learn to do the evaluation, simplified, they will learn how to evaluate. That's all it takes. The real learning of algebra starts in grade 7, to be honest with you, okay? Because I think that it's not that because they cannot learn. We try not to, because to be honest with you, algebra is quite abstract. I don't blame the kids, you know. Even if they can do it, they do it mechanically. You don't understand what it means, to be quite honest with you. Yeah, they can do it mechanically, I can do it, but why? I don't know. Is it you know? So that's the whole idea. That's the reason why we're about. You see, in learning, one important thing about mathematics is not so much that they can solve problems. It's good, that's a very good skill that they are supposed to acquire. But they must understand why they are doing it their way. There must be reason in the back. Why you solve it in this way? Please tell me. And what can they tell you? I don't know. That's what exactly the teacher is doing. I just follow exactly. We just copy everything exactly without understanding. This is called learning without understanding. I can learn, but I don't understand why you're doing it this way. They learn by hearts. When the things they learn by hearts, what happens? They tend to forget easily. So we talk about real understanding. Not only I can do, I know why I'm doing it this way. I can explain to you, yes, I do this because I can give you the reason. That is important. That means he shows his understanding of what's going on in the whole process. And that means they don't follow you blindly, okay? Yeah. So you see, one thing about learning mathematics, kids always say, I must know how to solve problems. Yes. But to me, what is behind mathematics is not so much simply solving problem. It's learning what? Skills. There are skills involved. And these skills are not just for mathematics, these are life skills. They must be able to see that what they learn in mathematics can be used in life. That's important. It's a life skills which they are doing then. And so therefore, unfortunately this time around, I don't have time to do it, but next time I'll show you why I say learning mathematics is actually learning life skills at the end of the day. What I'm trying to say is that the skill they learn in mathematics can be used in other areas, in other subjects, like in English, in science, or whatever that is, or even in everyday life, in other words. So what they're learning is a skill. That's important. All right? So kids must understand they're learning a skill, not just about mathematics or solving a problem here. Yes?
Can I ask for this question? Because it's 1 over 3 and 2 over 5. If the student is confused by the method of drawing 2 over 5, can they actually make it equivalent and to draw it in a straight line?
Can. That means, can they make it equivalent? Good. You are asking me. In other words, they are supposed to find a common denominator. Am I right to say that? In this case, which is 15. Okay, you are right. I can draw a long bar. You are right. Can. Okay, good question. I can draw a long bar. Okay, very long bar. I draw about 15 boxes, right? Whatever that is, I draw 15 boxes. A lot of boxes here, by the way, okay? But I don't know how many, 15 of them, yes. Okay, 15 boxes. And then, now, the question is, if you were to do that, you got 1/3. You got 2 over 5. And I want to make it into what? This is my common denominator. Am I right? So therefore, they must know that to make this, what they need to do. This will be a 5. Am I right? And this will be a 6. What do you call this fraction? There's a name for it. It's called what? Equivalent fractions. That means 1/2 is the same as what? 2 over 4, same as what? 3 over 6, same as what? 4 over 8. Am I right? They're called equivalent fractions. Yes, they can use the concept provided they have learned equivalent fraction, number one. Make sure they have learned. Yes, of course, they can do it that way. Nothing wrong with it, okay? So in that case, you're going back to the long bar, as is pointed out correctly. Secondly, they must also know how to find a common denominator. And that's important. Now, you ask yourself this question here. Can all the kids understand all this? Oh, I must find common denominator. I must convert all into equivalent ratio. Now, these are two different concepts altogether. So that means that in solving this word problem here, they must already understand these two concepts before they can do this approach here. Now, maybe for the smarter one, yes, I agree with you. I'm very smart, I can do it this way, and they can do it. But I'm thinking about those slower ones. Perhaps this method is easier to see, am I right? Because I don't have to think about equivalence ratio in this case. Equivalence fraction in this case. I don't have to worry about what? Finding common denominator. Because these are another two concepts which I must know in order to be able to use this concept to draw my bar model, correct? So I think in teaching, you must understand what concepts have they learned. If they have learned it, be my guest, use it. But if they have not learned it, don't try to force upon them. If they have not learned how to find common denominator, I say, okay, let's do it. By find a common denominator, say, teacher, what's the common denominator? I don't even know answer this term here. So that's important, okay? But the method is correct. So either way, there's no right or wrong answer. It all depends on your students, to be quite honest. If this year you happen to have a very good class of students who are very smart, they know how to do all this thing here, sure, by all means, you can do it in this way. But you happen to have a class, they're a bit slower, whatsoever there, step by step. You see? Yeah. Good question, by the way. Any other question you may have? All right. Have I answered your question here? Okay. Yes. All right, good. Let's see how it goes. Okay, I think I have done enough. How about your turn? Let me have a rest. Now, I pick the picture here. You can try them slowly. There are the 5 questions. Okay, anybody from the... Hello, anybody here? Much better, okay. Okay, yeah, you can try them slowly. Then you can discuss among yourself then. You can show me later on the board how you handle these 5 questions. Okay? Now, of course, I'm by the way, in this workshop here, I count literally from grade 1 to grade 2 to grade 6. So if you don't mind, try different types of questions here, okay? Yeah. This is all Pak-Ho, by the way. They're all Pak-Ho questions. Go show the bar model. On the board there. To put it here. The bar model, come on. Show me. Just put on the board there. Okay, so the first one, see we all agree with his way of drawing the bar model and the way he answered it. See, you put it there. Okay. All agreed? Same model, same way of drawing. Okay, good. Okay, all agree. Okay, so all great minds think alike. Okay, good. Yes. All right. Second one, anybody? Anyone here? Come on, show me second one. No, use the blue one, the blue marker pen. Go do it. Oh. Okay. All agreed? Same? Great, okay. Well done. Yeah. How about volunteer for number 3? Anyone? Have you tried number 1? Want to try? 3. Yeah, 3. Have you done number 3? Come show it. Don't be shy, just come forward and just show it. Okay. All agreed? All draw the same bar model? No. Oh, okay. Fair enough. You can see that now the kids may draw it differently. Same. Okay, I see draw differently. You all draw the same way? No. How do you draw a bar model? You draw a bar model? Same way? How to do it?
I got lost.
You get lost, huh? Okay, don't worry.
Yeah, I got lost.
Okay, never mind, don't worry. But answer all correct, isn't it? All of you, 75? Okay, now. What's important is that, yes, the kids may draw differently. And what you're drawing here is correct. The problem is, you use up 2/5 of the rice on the first day. So you're very correct. 5 parts, and you work out each part is, or 1 unit is 36, which is correct. The second day is what? 33. It's a bit less. So therefore, this little one must be 3. Am I right? Must be 3. So I cut a little bit there. Okay, so fair enough. So on the third day, then you try to do it this way, and you say, hey, well, I know these 2 parts to be what? 36, 36. Actually, What that is correct. I can say, since I know this is a little 6 here, right? Am I right? No, 3, sorry, 3 here, sorry. 3. It's a 3 here, right? Make it 36, am I right? So the kid can see that this is also 36 and 36, right? I can do actually 36 plus what? 36 plus 3. That's one way of doing it. You see that? The kids can do it in a different way. So that is basically, now you see why, in a bar model, people can do it, they can draw it in different ways. Another way of looking at it, they can also use a drop-down bar, which I've said before. You see, from day 2 and 3 onwards, I can drop it down. A long bar again. But I notice long bar, since I noticed 36 and 36, right? This long bar must be what? Must be 36 times 3. I know already this amount. And I know that over here, the second day is what? 33, right? This is second day, correct? So this must be the third day, correct or not? So the third day, quite easy to find already, am I right? I can take this minus 33, I get my answers. Am I right to say that? So you can see the way you look at the question. Kids can do it in different ways because the way they see can be different. I can drop it down. I show you what I look at the second and the third day. I can show you a very simple calculator just to get it done. So now you see that I can have different types of bar model. I can have different way of doing the calculation. There are 3 ways already, and still get the same answer. Well, that's one good thing about bar model. It's very creative, up to the kids. So our mind can be so fixed, it must draw it this way. No, sorry. The kids may draw it in a different way, and yet can get the same answer. Don't forget, the picture is only a visual aid, bear it in mind. It helps to solve a problem. That is important. Now, one of the things I want to emphasize here is this. When kids solve a word problem, yes, a bar model is a good visual aid, but what is important, they must show you they're working. That is more important than anything else. Don't simply give an answer without any working. That is wrong. You must insist that you must show you're working. Don't just give me a bar model and find an answer, period. That's not a way to do it. Okay, so I want to emphasize on this one here. Good, okay, so far I think of you are getting onto this bar model. Now you can see the different ways of doing the bar model. How about number 4? Any volunteer? Nobody want to try? No, try number 4. Come forward. I will erase some of the things here for you to do it. Come on. Then erase here. Come. Okay, thank you. Okay, yeah, thanks. You put there. Oh, the same way of doing it? No, okay. You want to show you all? Come on, tell me how you do it. Oh, so okay, you can see that there are different ways of looking at the same problem. Then you can do it, draw it somewhere there. Okay, good. Thank you. What she's doing is, this is not a part whole, this is a comparison model, which I'll touch on later on then about the comparison model. Okay, yes. In fact, the same problem can be, you can draw a bar model, this is a part whole. This is a comparison model. I'll touch on after this one here, okay? Kids can use either one. Both are equally right, to be quite honest. Okay, so once the kids have learned all the part whole model as well as the comparison model, they are free to use it in any way. But there are sometimes the problem has to be solved using the comparison model and not the part whole model. So, but in some question, either way, they can still solve the problem there quite easily. Okay, well done. Okay, all of you pick up very fast. Okay, so far. And last but not least, how about this one now? This one here, you see there is a whole number. There's a percentage, there's a ratio. My kids say, wow, all the things all come together in one word problem there. Kids say, hey, teacher, how to do this one? All come together, like big one happy family, this one called. This is one big happy family question. Okay. Anybody? Oh, this black is not very good, hard to erase. I still take away this one. I think only the blue and the red is easy to erase. I'll take away this one. Put it away somewhere. Want to try the last one for me? Come on. Any volunteer? Okay, good. Yeah. Okay, all agreed? Or it's the same bar model or different bar model? To draw one long bar, by the way, is a part whole model, correct? The whole big of many parts inside there. Okay, good. All agreed? Fine. Is it the same word that you're drawing? Different again. How do you draw it, by the way? Show me.
Initially, I draw like that.
Then
I realized the kids may not understand like 40% equals to how much.
Okay. Yes. Now, one thing about percentage and fraction, it's a bit tricky. Let me just take you through this one more time and basically going to show you about the thought process, how the mind will look at it from different perspectives. Some students, when they see percentage, I say 40%, 60%, straight away, they are very smart. They deal into 10 equal parts, 100%. So what they will do is they'll draw 10 equal parts. They can do it this way. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 equal parts. And then they say that, look at the question again. 40% are men, so that they can see these are men. Am I right? 40% means what? 4 boxes. And the rest must be what? Women and children. Am I right? So they can see it straight away. And they say that altogether there are, how many people are there? 270. That's one way that they can see it quite easily. And of course, once they do it that way, straight away they will know that each box is what? 27. Straight away they will know that 27. So I can say, okay, I know that's 27. So on the 27. So this is all 27, 27, 27. There's 6 27. So in other words, you have 6 27s here. So in other words, this part here basically is 6 times 27. Am I right? The children there, okay, 6 times 27. They know that from what they've been doing. And if they have done the ratio, since now you use a ratio, I will what? I will split into what? 5 and what? 4. No, 5 and 4. There are 2 ways that they can do it. They either use the drop-down bar to draw 5 and 4 to distribute this number here. That's they can do it in that way if they want to. Okay, I can draw another long bar here. Okay, 5 and 4. So okay, altogether how many parts would I have? 9 parts. So they have a 9. So they will have the 9 parts there. So in other words, 6 times 27 is what? Who can tell me the answer? Quick. 162. So this equals 162. So they can see that 162 will be, so altogether they will have what? 1 part will be what? 1 unit must be equal to 162 divided by 9. Am I right to say that? They will do that. So therefore, the question, what they want is how many children are there? Children got 4 units. So I can say that therefore 4 units must be equal to 162 divided by 9 times 4, and I get my answers at the end of the day. So that's one way that they can do it. Or another way, they don't want to be so cumbersome. Once they see this one, they do the ratio, this is a smarter one, they say, I know how many children are there. It must be what? It must be 162 times what? 4 over 9. So we can write it down in this way also. So sometimes the kids may not want to go to a unitary method. But for the slower one, so to speak, you must take care of them. They will go step by step in this way. So either way is fine with me. Because students may progress at different pace. Okay, so I think that's one way of doing it. But some people don't want to be so troublesome. I must draw 10 units. What they can do is what? That's all they do. Simple, very short. Shorter bar, 40%, longer bar, 60%. This is men, am I right? So they say this is men. Okay, and this is women and children. And the number of people here will be what? 270. Straight away, they can do it in this way. And straight away, I know the number of women and children here, which is what? Number of, is equals to what? It's equals to 60 over 40 times 270. Again, then from there, I would learn to what? I would learn to distribute like what I'm doing here later on then. Because I know the total number here, right? Which is this number here. Then after I work it out, I can still go back to do it in this manner. Because that should total out to be 162 at the end of the day. So you can see there are many ways to draw the bar model. Either this way, that way, so that there are different ways of drawing it. Depending on how the student look at the questions and what they understand, and they can do it. But one thing I always advocate, that is, try to draw a bar model as simple as possible. Sometimes I see kids, they draw a bar model, looks very complicated. It's so complicated, what happened? After a while, they get confused by themselves. Say, I don't know what I'm drawing now. Am I right? It's quite common, but they've seen it. So tell the kid, try to break it down into smaller parts. You see, the way in which I'm doing it, I try to separate the concept of ratio from percentage. I break it separately. The reason why I had to drop down this one here, you know what I'm doing here? I try to separate the idea about percentage first, get the percent done first, then followed by the ratio. That's one thing. For kids who have one thing, I can only do one concept at a time. But for kids who say, I can do both together, fine. These are all together. So the question is not so much of whether or not it's right or wrong. Everything is correct here. But it's the mindset, how the mind works. Do I separate two concepts? I do one first. Once the one is done, I do a second. I can apply the second concept to solve the problem there. These are the final point in teaching. And this is the final point, how the students look at the question. That is important. So now you know where I'm coming from. I'm looking more at the thought process than the actual answer. That is what matters in learning mathematics. Okay? Yes. All right, why don't we take a short break now, and then, since I've been here for quite some time, and about 10 minutes, you'll come back here again. Then I think, what time is the last, 11th, 45, okay? So, yeah, so take a short break, about 10 minutes, I'll come back again, I will wrap it up, then we'll go for lunch. All right?
It's coffee and tea downstairs.
Yes. Okay? Now, let me touch on the next one. It's called the comparison model. This is the second type of bar model that is quite commonly used, okay? Now, the word comparison means what? It means that you compare two or more quantities. That's a comparison model. You compare things, okay? And in this comparison model, there are also three types. I talk about these three types here. One is called the additive comparison, and the other is called the multiplicative comparison, and the last one is multiple comparison. It's all put together. So you get these three types of comparison models, okay? I'll touch on all three of them. Now, just earlier on, I've seen some of you using the comparison model, which is good anyway, but it will fall into this category here. Now, let's take a look at the first one. This is called the additive comparison. 54% of the members of a book club prefer reading fiction over non-fiction. The book club has 500 members. Find the difference in number between those who prefer reading fiction and those who prefer reading non-fiction. So it's a comparison, am I right? You compare both types of readers. One type, they like reading fiction, another type, non-fiction. So therefore, what can we do? We draw a comparison model, straightforward. The label is important. Those who prefer fiction, those who prefer non-fiction. We draw it this way here. And we can see that, since we get 54% of members prefer what? Reading fiction. That means what? 46% must be non-fiction. Am I right? And the total is 500. That's the number of members. So this is a whole, these are the parts. Part whole again. But even then, the part whole, I will draw it using the comparison model. And the question is that, what's the difference in number? Here's a number here. And I think once you see that, it's a lot easier to solve it. How to handle this one here? Now, by the way, this is all in percentage though. It's not whole number, by the way. This is okay. The whole number is not easy, but it's not a whole number. They cannot say 500 minus 54. Sorry, that's wrong, by the way. They cannot do it that way. So the way is that because this is a percentage, and that's how they will handle it. Because they know that the difference is 8%, am I right? That is important. The difference is 8%. So in other words, you're talking about 8% of what? 500. Now, 100% same as a fraction. It's a part whole, am I right? It's a part whole. So therefore, percentage in a way is also a fraction. When it's 60%, it's not 60, it's what? 60 over 100. The only thing special about percentage is what? It's a fraction where the denominator is divided into what? 100 equal parts for the whole. That is the key point. Still a part and whole as fractions. Except in the case of a fraction, the whole may be 3 parts or 4 parts or 5 parts. But the percentage is 100 parts. That's the only difference. And we can name to it, we call it this kind of fraction, percentage, that's all. So therefore, I know that the difference must be what? Must be 8%. I can work in this manner there. You see that? So this is what we call the additive comparison, because I only use what? Addition and subtraction, that's all I'm doing, nothing else. That's why it's called the additive comparison model. Now, another kind of the multiplicative comparison. What does that mean? When you see the what? How many times Alex has 3 times as much money as Ben. 3 times as many as. Now, these two expressions are very commonly used in mathematics. Am I right? You make sure that you can understand what it means. As many as much as. Ask them, who has more? A has much as B. Who has more? A has more or B has more? You ask them this kind of question to figure out, okay? So therefore, say Alex has 3 times as much money as Ben. Who has more money? Alex. Okay. Total sum of the money is what? $572. How much money does Alex have? So again, you draw a comparison model this way. It's a 3 times as much as. So in other words, when Ben has 1 unit, Alex 3 units. That's what it means. Okay, when they say no, twice as much as is what? 1 unit to 2 units. Am I right to say that? So that's how you would do it. And the total is what? 570. That's what's given to us. Now the question is, how much money does Alex have? You see, I put a question mark here. That's important. I know exactly where I'm supposed to find my answer. I want to find, how much Alex has. And once this is done up, I think the solution is very easy to do already, because these are the same size, all the units. Altogether, 4 units, all right, is equal to 570. I work it out. 1 unit again, as before. Then I've got 3 units, and that's the amount of money that Alex has. Straightforward. Okay, so this is not difficult to do it, but you have to be careful about the use of the terminology, the phrases that we use in the question there. Sometimes kids may not understand those words and the use in the question. Okay, so we're just supposed to have a break. Now we have a break already. Let me just go on, okay? Now, we are talking about multiple comparison. This one means that you have different types of comparison all together in one word problem. Now, you look at this question here. In a basket, the watermelon is twice as heavy as the cantaloupe and is 7 kg heavier than the pineapple. The cantaloupe is 3 kg heavier than the pineapple. What is the mass of each of the fruits? My goodness, this one, lots of things are going on there now. When students look at this question, don't try to solve it first. Ask them, how many types of fruits are there? The first thing you have to know. You see, one thing about students, they are so eager to solve it. Read it, or to solve it. Come on. Slow down, tell them. You don't even fully understand the question. Why? How can you solve it immediately? Okay? So ask them, how many types of fruits here? Okay, 3 types. All right? So let me just, assuming that, I'm teaching the students, they say, okay, they say, what are the fruits here? They say, I have what? Watermelon. Okay, say watermelon, right? Watermelon. Okay, so watermelon. And what else do I have? A cantaloupe. Okay, cantaloupe. Okay, what else do I have? Pineapples. Okay. 3 types of fruits. Okay, good. You see, at least they will know. Now, the watermelon is twice as heavy as the cantaloupe. Which is heavier? Watermelon. Okay, watermelon. Cantaloupe, of course, is lighter in this case. But then how about the pineapple? Say what? And it's 7 kg heavier than the pineapple. Which is heavier, cantaloupe or pineapple? The cantaloupe and is what? The watermelon is twice as heavy as the cantaloupe, and it's 7 kg heavier than a pineapple. So what happens? You compare what do you compare? You compare watermelon and pineapple. Am I right?
Yes.
So among all the 3 fruits, which one is the heaviest? Watermelon is heaviest. Okay, this is heaviest. Okay, this is heaviest, right? Heaviest. Now, and the cantaloupe is 3 kg heavier than the pineapple. So, which fruit is the lightest? Pineapple. Ah, good. So this is my lightest, right? This is the lightest. So this is in the middle, huh? Okay? This is in the middle. Now, good question now. So they will know straight away in the mind, the heaviest fruit, the lightest fruit, and the one in the middle, fine. Next, how to draw a bar model? Should I draw the pineapple first, or should I draw the cantaloupe first? But there are 3 sets of fruits, right? Now, that's one of the things that they have to answer this question. And I'll tell you how to teach them this one here. You see, which fruit among the 3 is used to compare with the other 2 fruits?
Cantaloupe.
Cantaloupe. Okay. Pineapple. But how about cantaloupe compared to, okay? But these are lightest, right? Okay. So how would you draw the bar model? If you have 3 bars, I don't know how they look like. Okay, let's say I don't mean this correct, okay? I simply just draw it. Let's say this is watermelon, this is cantaloupe. Let's say I draw something like this. Pineapple. Something like that. Then that's good enough. Or should I put it the other way around? Now, so that's a question that you still may wonder, which one should I draw first? How would you draw the bar model? Now you got 3 objects. Okay, now I'll show you this bar model, you see what's going on. I put the bar model right in the middle. I choose the lightest one, the smallest quantity in the middle. Because this one, the lightest one, has also been used to compare with what? Both the watermelon and the cantaloupe. Am I right to say that? Yes. So it's easy for me to draw the bar model. Now look at it again. When I compare the pineapple with the watermelon, what it says? It says that the watermelon is what? 7 kg heavier than the pineapple, right? 7 kg. Okay? And when I compare the cantaloupe with the pineapple, what it says? The cantaloupe is what? 3 kg heavier than the pineapple. So 3 kg. You follow me? Number 1. Now, that's not the end of the whole story yet. But there's still a comparison between what? Watermelon and cantaloupe. Twice as heavy. That means what? It's a ratio 2 to 1. Am I right? 2 to 1. Okay, wait. Actually, as much as, actually it's a ratio. Do you realize it?
Yes.
It's a ratio. It's just we use a different language. We don't call it ratio. We say, twice as many as. That's all. But it's a ratio, basically. So therefore, it's a ratio. That means, if I make this to be 1 unit, this guy must have 2 units. Am I right to say that? So that's how I draw the bar model. Now, can I draw it another way? You can, by the way. I'm not saying you cannot. I can put out the watermelon, the cantaloupe, and the pineapple also. But be careful about when you compare the length. But they break properly. But in my case, by the way, I'd rather choose the lightest one right in the middle. It's not easy for me to do a comparison. Not that the other way of drawing it is wrong. It's still correct. I can still draw it in this way. If I draw it in this way, I can still do it. You know, I can still do it. So meaning that if I do it this way, what I do? 7 kg, but this 7 kg is compared here. Am I right? Yes. I must be able to do it this way, and then this one compared with this one, it must be like this. Am I right? So there are many ways of doing it. You can do it in many ways. And then compare with the pineapple and the cantaloupe. This is what this part here is 3 kg. Am I right to say that? But hard to read this kind of a bar model. It still makes sense, though. By the way, it still makes sense. But I will try to choose a bar model which is easier to understand. That's all I'm doing, and easier for the kids to understand. So for that reason, I think if you put the lightest one in the middle and compare to the other which is heavier than the pineapple there, it's easy for you to draw the bar model. It takes some practice for the kids, to be very honest. So I think if we do teach them at the upper primary level there, teach them through step by step. Of course, when I'm telling you, I can do it very fast. But in the classroom there, you really have to slow down and show them, you know, why you do it this way, step by step. Help them to learn how to draw this kind of a bar model. But once this is drawn, to find the mass of the 3 fruits, a lot easier already. Now, my question is that, how to find them? How to find them? Okay, so look at the solution now. Where is my 1 unit? Question is. You see, the only place you have a unit is where? Am I right? That's the only place that you have. And you can compare these two, watermelon and cantaloupe. So to me, the 1 unit refers to what? These units here. Am I right? This is 1 unit. So if there's 1 unit, this is what? 2 units. How about this one? 1 unit less 3. Pineapple is a 1 unit less 3. You see what I'm doing now? If I know what is 1 unit, I know everything already. Am I right to say that? If I know cantaloupe mass, how much is that? I know watermelon, twice of it. How about pineapple? 1 unit less 3 units. Less 3 kg. That's exactly what's going on here. Can you see the lines of thoughts? I'm just verbalize it for you people, that's all. So that is what's going on in this type of problem. This is called a multiple comparison model. A lot harder, yes. I must say that. It's for what? Grade 6, isn't it? Grade 6? Grade 6, huh? Okay, fair enough. Now, in other words, you can see that in doing the bar model, the thought process is very important. It's not about solving it, how they get started, what I'm looking at the question there, how I try to how to translate those words into a picture, which is a bar model here. It requires a fairly much of the thought process involved in this question. I will not straight away give the kids, oh, you draw it this way, and just do and say, the kids, oh, I know. Come on, they don't know yet. They only know when they draw it, they can solve it, they can see this, it's quite easy. But they have no idea of why you want to put the pineapple in the middle, why these two must be, next to the pineapple there. What's the rationale behind it? That is a key point in learning. There must be a reason why I draw in this manner. That's why I take the trouble to explain what's going on. Solution is very easy. And even before I look at the solution, I will know that if I know cantaloupe, the other two just fall a lot faster. Fair enough? So that is a kind of a thing. Even before I know the answer, I know my thought process. That's how I should process it. That's how I will find my answers at the end of the day. Are you with me? Good, huh? Okay, good. Are you with me now? Let's look at some more example, okay? Another comparison of 3 ladies, their age. Betty's age is half Anna's age, while Chloe's age is twice, 3 times Betty's age. The total age is what? 84 years. Find the ages. Now, 3 ladies, different ages. Okay. Okay, no more fruits. There's people now. Whom do I have? I got Betty, right? I got what? Anna. I got what? Chloe. Okay. 3 lovely ladies of different ages. Now, of course, I have to draw the bar model depending on the age. Who should I draw? Okay, how should I do it now? Let us say that if I use my reasoning in my previous questions there, what should I do? I'll try to who's the youngest one. Am I right? Yes. Okay, good. So among the 3 ladies, who's the youngest one? Let me see. Betty's age is half of, and so Anna is older, Betty is younger. Good. So Chloe's age is what? 3 times what? Betty's age. So it's older. Also, who's the youngest? Betty is the youngest. Am I right? Okay. So maybe I should put Betty right in the middle. Fair enough? I don't know whether I do it this way. Let me see. Oh yes, true enough. Okay, I put it in the middle there. Okay. Yeah, so I put it in the middle there. It's a lot easier for me to do the comparison. Because now I have Betty compared with Anna. Anna's what? Because the Betty is half of Anna's age. That means Anna's age is what? Twice Betty's age. Am I right? Twice. So, and Chloe is what? 3 times older. So 3 units. I will draw it this way, okay? The total age, what? 84 years old. Now, once I see that, now this is a comparison model. Actually, now I got multiple comparison. All right, so therefore, once I do that, what should I do? I work out. Everything is there already, correct or not? So straight away I can find out, 1 unit, 2 units, 3 units. Case done. Straight away. You see how the bar model, once I can do it, this process is a piece of cake. Am I right? They can easily. Once they get this picture, this one is almost, it's given. They can just do it. You can see the power of the bar model here. But if they don't have this picture here, looking at this question here, you think they can solve it immediately? I don't think so. They cannot do it. So far so good? Okay. By the way, you can take a snapshot if you want to. Just feel free to take a snapshot and then compare with your notes I'll give to you later on then, okay? And yeah. Oh, it's about lunchtime now. Okay, never mind. Let's finish up hopefully I finish up my last Okay, I move on to the next one. Okay, here's a practice question. Now, I don't think you can finish all of them, never mind. We try for a few minutes if you want to try it. Then we can break for lunch and come back, carry one again, not a problem. Now, again, you have the 5 questions here. And this one, trust me, I think they will use comparison model to do the comparison for orders then. Now, slowly, anyway, of course, the first one usually is the easier. I will start with the easier one for you. You can try the first one first. After that, maybe you can go for your lunch and see what happened then, okay? I'm talking about what? I'm talking about curry puffs and chicken pies. Oh, okay, that's easy. There's only 2 items here. Curry puffs and chicken pie. It's okay, that's it. Now, can you do that one there first? Okay. Jimmy baked 247 curry puffs and chicken pies. There were 15 more curry puffs than chicken pies. How many curry puffs did he bake? Okay. That one should be easy. Well, you write very neat, your writing. I think you girls write very neat, you know. Neither than my writing. I cannot write so neat anyway. Okay, first one, quite easy. First one. What kind of model is this one? What kind of comparison model? What type? What type of comparison model? Come on. Is it additive? Is it multiplicative? Or is it multiple? On these three types. Vanilla, chocolate, or strawberry? I don't have 4 types. Additive, right? Yes. On the 2 types, right? I have what? Curry puff and chicken pie, right? So I got curry puff, okay. Curry puff. Chicken pie, fair enough. That's what I have. So, okay, which has, what did he make more, by the way? Chicken pie or curry puffs? Curry more, okay? So curry puff has more, right? The kid will do, okay? More means what? Longer bar, am I right? Longer bar. This one is what? Less chicken pie, shorter bar. You see? There's one thing, longer bar, that's it. And it will say what? They have altogether how many? 247 altogether, okay? So 200 altogether. You see, as they read this, draw it, that's simple as that. As they read it, just draw it then. Then it says what? There are 15 more curry puffs than chicken pie. Oh, the difference is about 15, am I right? And that's it. So, how many curry puffs did he bake? Oh, okay, I want to know this one here. That's it. And once you draw this bar model, the answer is quite simple already. Am I right to say that? Yes. Now, can I use the concept of units? Where's my 1 unit? Hey, but say that, but here there's no ratio, there's no fraction. Where's my units? In this case, even though it's not a fraction, it's not a ratio question, we talk about 1 unit. Where's my 1 unit? This is my 1 unit. You follow me? I know that these 2 units together is equals to this one is what? Oh, sorry, get it. And once I have that, what's my answer? 2, 3, 2. I know that 2 units is 2, 3, 2. So 1 unit is what? 1 unit must be equals to 2, 3, 2 divided by 2, which is equals to 1, what?
116.
1, 6.
16. 116.
116, right?
Yes.
So 1 unit is 116. I want to find curry puff, right?
Yes.
So curry puff must be what? 1 unit plus 15, am I right?
Yes.
And so here's my answer already. You see that? I feel like it's about 1 unit. How do I want 1 unit? I take the smaller one to be 1 unit. That's it. So that's how you do it. Can I take this to be 1 unit? You can also do that. But if you take this to be 1 unit, this one will be what? 1 unit minus 15. You see that? So that's a different way of looking at it. If you take this to be 1 unit, this one must be what? 1 unit minus 15. Now this is another way of looking at that thing there. So that means I have 1 unit plus, no, sorry, not 1 unit, listen, 1 unit plus 1 unit minus 15 is equal to 247. This is what? Curry puff. This is what? Chicken pie. Add together is 240. Then I have to learn how to manipulate this one here. Do you see that? So you have to be careful about orders. It can still be done in a different way. I'm not saying which is a better way, but I'm just sharing with you that there are two possible of looking at the 1 unit. In my case, I choose the 1 unit to be the smaller one, the smaller quantity. But some students want to choose, I want to choose this bigger one to be the 1 unit. It can also be done. I don't know about your preference, but I choose small quantity for 1 unit is my personal preference. I thought easier to do the addition more than the subtraction. That's why I would do it in that way there. But some kids know to do subtraction first. Okay, up to them. I said, I'm not going to say that they can't do it that way. Okay, so final question? Clear? About the first? So I'm going to show you, where the 1 unit is, even though there's no fraction or ratio in this question. Okay, I think it's time for lunch. They said at 12 o'clock we have to be there. They want to make sure the food is hot. So I will break for lunch now, and then we'll come back in 1 hour's time, and then we will try to do the next 4 questions. How about that? Okay? Let's break for the lunch. Okay, let's go for lunch, come on. Don't let the food get cold. How do you do the second one? Is it by fraction already? So you can have a fraction. No, this is why one doesn't work. Okay, anyone? You got it? Okay, you want to show? Come on.
The trees are number 2, right?
Number 2, yes. Yes, number 2. Okay, good. Yep, thank you. All agreed? Same way? The very straightforward one. This is a straightforward comparison, okay? Yes, okay, so that's basically what it is. Now, I will skip number 3. Number 3 you can do it by itself because of time constraint. It's quite similar to the one which I've shown you about the age and all the things that you can do. Now, I want to jump to number 4. Try number 4. About fraction again. Got 2 jars. You compare 2 jars, okay? Jar A and jar B. And you are given the comparison is in terms of fractions, by the way. How do you draw this bar model to solve it? So anyone come with number 4? It's not difficult, to be honest with you. This one's quite straightforward. Okay? Are you there with me? Anybody got it? No? Okay, never mind. Anybody have got it? Or still working on it? Okay, sorry for my interruption. Before you work on it, attention please. What is the key point here in this question number 4? When you read it, what the first that strike you? The first thing that's important. You have to keep asking where to start, am I right? Where to start? What can I do? You see, the whole question is only one area that gives you the concept of equality, something being equal. And the two jars, something being equal. The key word is this. Half the capacity of A is equal to 2/3 the capacity of B. That is the only thing you get equality. That is a starting point. Because you must know where to start, obviously. Either I got some number, and it happened that these two have some numbers there. Unfortunately, the numbers are what? A fraction, fair enough. Doesn't matter, but let's say number. Something is equal to something. That means the 2 bar, whatever that is, I will just draw something first, like this. They must be equal, right? Equal in length, am I right? Equal. Let's say this is A, this is B. Something being equal. I must start with here before I think of anything else. I don't even think about the ratio or about the fraction whatsoever. I just think of being equal to the first thing, A and B. Now I put in the fraction. Because it says that this, now let's look at jar A. This is only what? Half of jar A, am I right? That means the full jar must have another equally long, same as this one, right? Same. First thing. How about jar B? This is about what? This is about, where says that? About 2/3, am I right? 2/3, that means this is 2/3, this is only what? 2/3, that means there's another something like this, am I right? That's it. So as I read, I try to complete the picture. And that's all I'm doing. Because the only starting point I must look out for is where they are equal. That's how you complete this bar model. But once you have that, then life is because what they want to do now is what? Find the ratio of these 2 jars. How to find it? Obviously, you can see that now. This 1 unit is bigger than this 1 unit. This is smaller units. So I can see that this unit is the same as what? 2 small units, am I right? So I can divide it into 4, am I right? I got 4 units here. Now you see, I got what? 3 units here. These units are all the same size. Am I right to say that? Answer is out already, straight away. You see that? I want to show you the thought process. Actually, it's not a difficult question. It's how you look at it. Now, of course, now I don't write the whole solution there. Fair enough. I just verbalize it. But for students, they're supposed to write it down. Fair enough. I want you to understand is how the students are supposed to learn to think the solution before they even write it out as such. You follow me? So therefore, in teaching mathematics, how to think, number 1. If you don't know how to think, then what to write? Nothing to write. If I cannot think, I cannot write. Am I right to say that? It's like that, then I can write it down. The only problem which they face, okay, sir, I understand now, but I don't know how to write. Fair enough. Now that's the next question, how to present. And then you have that, okay, if you tell me, you can verbalize it, tell me exactly what I have to write, okay, you should write this. Fair enough. So in solving a word problem, it's not so much of straight away, I jump and solve it. No. Where's the key point? Something being equal for me to start with. That's what I want you to understand. Are you with me? But I know that after heavy lunch, it's a bit difficult to think very hard. Okay, never mind. Okay, I will, now, I will let you do the number 3 and number 5 by yourself. All right, they're quite straightforward. You can go back and try because of the time constraint. I have to let you do it. I'll go to the next one here, which is the before-after model. Before-after model, it used to be in Singapore, used to be in our grade 5 and 6. They have this one here. But I think for the past couple of years, they brought it to grade 4. Our grade 4 students start doing very simple before-after model. In Eduseeds, I think we just stick to about grade 5 and grade 6. We did not bring it down to grade 4. If I start doing it, I think they will cry. The poor kids will cry. I see this one here. Never mind, okay? Now, this kind of model is to, this is a situation what? You have something before. Something happens. As a result, the whole situation changed. It's like you take a bus. When you board the bus, there's only about 5 people there. But the next stop, some can get down from the bus, some can get onto the bus. So number change. So this is a kind of a thing. Something happens. Okay, and there are many such a question. All right, now, so how to handle this kind of a bar model? Now, Jason has had 3 times as many stamps as Lena. Later, Jason gave 46 stamps to Lena, such that they both had the same number of stamps. How many stamps did Lena have at the end? Okay, so something happened. We have some stamps. So before we know, who has more before now? This has more. 3 times more than Lena, fair enough, okay? But later, what? Jason give some stamps to Lena. Something happened there already. The end result, what? Both have the same number of stamps. So that's it. Now, the question is that when you draw a bar model, how should the kid draw? Okay, if you were to teach this kind of a bar model, whether it's grade 5 or grade 6, my advice is that please don't draw 1 bar model, draw 2. 1 for before, 1 for after. That's easier. So your mind will think together at the same time. Okay, I draw. Now before is what? 3 times as many, right? Okay, so I draw before. Simple. Right? I will know how to do this comparison model, right? This is a comparison model. Okay, this is 3 times as many as Lena. So I'll just put it down there. But after, what happened? Sorry. He gave 46 and then the same number of stamps, right? Now, if you look at it, is it very obvious that to just say, literally move this box down here to make it to be equal? Am I right to say that? Now, one thing they have to understand, the total number of stamps never change. Something never changed in this case. So no matter what they do, it never changed. It's just that the quantities from one hand go to another hand. That's all. So that's what it is. So you know that therefore this one must to be the same. So this one must be 46. What else can it be? Am I right? So that's straightforward. So therefore, question is that how many stamps did Lena have at the end? 92 stamps. Fair enough. Straightforward. These are very easy before-after model. You draw 2, and usually this one we will do it, I think, in grade 5, if I'm not mistaken. Yeah. So I think that's a very simple before-after model to begin with. Now let's look at something a bit more, not so straightforward perhaps. Ruby had $163 and Laura has $50. When their mother gave each one of them an equal amount of money, same amount of money, Ruby has twice as much money as Laura. How much money did the mother give to them? This one, at first, we know how much money they have. Am I right? Ruby, there are only two kids here, okay? 2 children here. First one is Ruby and Laura. Of course, look at it, Ruby has more money, fair enough. But mother gave them some money. The same amount of money, by the way, it says. But as a result, what happened? Ruby now has twice as much money as Laura. At first, you look at this one here. Is it twice as much here? Not quite. In fact, more than twice, am I right? But someone, when the money given by the mother to the two children here, seems that now it appears that Laura has a bit more money. Because at first, if you look at the ratio, it's a lot wider, but now the ratio again it's only 2 times as much as. Okay, so that's the kind of thing here. So something changed at the end of the day. Nothing remained the same, okay? The question is, how much money did the mother give to them each. So the unknown is the amount of money the mother gave to both of them. What's the amounts? How to draw this bar model? Same. I draw it before. Am I right? That's quite easy. So I know that the difference at that time. I can straight away. Oh, by the way, even though this number is not stated there, when they draw, they can straight write it down, to be quite honest. Nothing wrong with it. In other words, when you do a bar model, even those information is not given, but it's being implied. And they know already, be my guest, I'd rather put it inside there in case I need to use it. That's okay. So I put there, so I know the difference is 113. Now, once I see that, then I know that when the money given to them, it seems that the difference between them is a bit narrow. I mean, the ratio is a bit better. Am I right? So how to draw the after now? See, to draw the after, I put it the other way around. Now, you can add also, you don't have to add over here, you can add behind also. Why I want to add behind? Because I don't want to change this difference here. You see, I keep this to be 113. You hide this two, this before, right? After, I add these two, same amount. You see, the way you draw a bar model, it can be quite creative, okay? Instead of putting the yellow one over this side, I put it on the left-hand side. But once I do that, now the ratio is what? This amount, now Laura has so much money there. This amount now is what? It's half of this amount, am I right? So that is how they would draw the bar model. I have not talked about how to calculate yet. I'm only talking about how to draw the bar model. It's a thought process. Help me see. I don't look at all this number there. The number is only here 5. But when I draw this one here, I based on, so much money given. Now Ruby has twice as much as Laura. That's all. Now, of course, once I get this one, I can do my calculation. How can I do my calculation? This is the original, am I right? Now, once I put in the numbers there, you think it's easy to find how much money the mother has given them? It's a piece of cake. Straight away, am I right? I don't say anything. The kid can say, oh yeah, I know how to do it already. Correct or not? Yes. You see, picture helps you to understand it very fast. They can straight away do it. So now you can see the power of the bar model. If they do it correctly, the answer just falls out like nobody else's business. But the harder thing is that if you look at the question there, say, where to start? Am I right? Where to start? Picture helps. You can see the power of the bar model here. Okay? This is not really such a difficult one, but just show you what happened there. And you can see that I will draw it. Rather pack it on this side, I pack it on the other end, on the left-hand side, to make it easier for me to understand. You can put it up here if you want to, but you have to really think about that. Then this yellow button will be longer here and there. Then you decide how to cut it later on. Then so I try to avoid that kind of complication. I will do it in this manner there. In other words, try to make the bar model as simple as possible, so that it's easy for the kids to understand, what is presented in the question there and how they can solve it later on. All right, so I just give you the answer here. That's quite straightforward already. Am I right? I don't know about that one there, so I just put a question mark there. Question mark plus 50 is 113, so I can work out how much money the mother gave to each one of them. Okay, I show you this one. It's only the video. Now you watch this video. I give you you can take a shot. This is, you can look at it in the YouTube there. You can take a shot of this one. You can go and view it at home if you want to. But this also before, after. You take a shot first, and then I will play this video. Okay, I played the video.
Hello, boys and girls. Today, we're going to do a before and after model concept. First, let's take a look at the question. There were 60 more blue ribbons than white ribbons at first. After giving away 3 times as many blue ribbons as white ribbons, there were 10 more white ribbons than blue ribbons left. How many blue ribbons were there at first? Step 1. Let's draw the before model. So there are 60 more blue than white. Step 2. We draw the after model. There were 10 more white than blue. Step 3. This is the important step. We have to identify the change. Yes, 3 times as many blue ribbons as white ribbons were given away. Now, it's usually easier to add than to subtract. Therefore, in this case, I'm going to work backwards, starting from the after model. So what I'll do is, we'll put back 3 units to blue and put back 1 unit to white. After putting this back, remember, there's 60 more blue than white, just like the before model. Okay. What I'm going to do also is now to label them units and the parts. Step 4, we will have to rearrange the white. What we do is try and put the number values together and put the units in front. So blue and white will be 1 part, 1 unit, and a 10. And this is 60. Now, can you identify what to do next? Very good. Can you see that? 2 units is actually...
Stop here. Now, can you figure the answer already? No. Let me play again.
310 plus 60, which is 2 units is equal to 70. Therefore, 1 unit is 35. Now the question is, how many blue ribbons were given away? Looking at the model, we need to look for 3 units.
Yeah.
So 105 blue ribbons were given away.
Okay, you got it? Still don't get it? Huh? Okay, let me play again. Okay, one more time, then I'll play again. One more time. Now, watch very closely this one, okay? If you're not sure, then you can go and look at the YouTube later on. Go ahead and you can look at it. Then I play one more time for you. Look at it.
Hello, boys and girls. Today, we're going to do a before and after model concept. First, let's take a look at the question. There were 60 more blue ribbons than white ribbons at first. After giving away 3 times as many blue ribbons as white ribbons, there were 10 more white ribbons than blue ribbons left. How many blue ribbons were there at first? Step 1. Let's draw the before model. So there are 60 more blue than white. Step 2. We draw the after model. There were 10 more white than blue. Step 3. This is the important step. We have to identify the change. Yes, 3 times as many blue ribbons as white ribbons were given away. Now, it's usually easier to add than to subtract.
Yes.
Therefore, in this case, I'm going to work backwards, starting from the after model. So what I'll do is, we'll put back 3 units to blue and put back 1 unit to white.
Yes.
After putting this back, remember, there's 60 more blue than white, just like the before model. Okay. What I'm going to do also is now to label them units and the parts. Step 4, we will have to rearrange the white. What we do is try and put the number values together and put the units in front. So blue and white will be one part, 1 unit, and a 10. And this is 60. Now, can you identify what to do next? Very good. Can you see that? 2 units is actually 10 plus 60, which is 2 units is equal to 70. Therefore, 1 unit is 35. Now, the question is, how many blue ribbons were given away? Looking at the model, we need to look for 3 units. So 105 blue ribbons were given away.
Because now, what has been done so far? Look at it. A few things they have done. You see, he drew the before model and after model. But in the working, he worked backward. He put back. He tried to restore from the after model, try to restore the before model. So this actually is, now I put back, this is a before model already. Am I right to say that? So with the before model, then you know that the difference must be 60, number 1. So that is the key point. He worked backward. Going from after model back to the before model, the first step. After that, what happened? Well, this part, of course, we do not know. This is here one part, remember that? But he knows all these units because he knows that because they give us 3 times as many blue ribbons as the white. So he knows that. So therefore, once you put back, you can see the difference. So therefore, what happens is that from after that, he what? Rearrange it in this way. Am I right? So he tried to rearrange it, you know. So once they've done that, so he will see that, you know, so that he will see that once he rearrange this one here, now this one is the same. But once he rearrange this one here, he can see that up to this point they're equal. Am I right? So that's why when they draw about things must be quite equal. That's one of the things there. Then he can see that these 2 units is basically over here. Correct? Which is what? 10 and 60. That's how you work out the solutions as such. That is the point here. It's a very creative way of solving this before-after model. And this is quite typical of our Singapore types of before-after model for the primary 6 students or the grade 6 students as such. To share with you. Okay? Yeah. All right, anyway, if you want, you can go to the YouTube there. But I give you the link and you can watch it again. Try to pick up the gist of it, you know. So you can see that before-after model can do a lot of other things as such. Now, you want to try some on your own? Don't have to try all, by the way. I think just try a few of them. I'll try the first one and see what happened. The first one is about the age. I'll give you a hint here about the bar model. You had the before model, right? About the current age. And you want the after model, which is about after how many years? After a period of time. And you know what happened? What's the age up? After that, they say that's what? It's twice as old. Am I right? Bob is twice as old. I'll give you a hint here. Remember just now there's a one I draw the bar model about on the left-hand side? Okay, there's a hint. You draw it, then you know what I'm talking about. So before your model must be like this, right? Before. What are the people? Bob and Eva. Eva is younger. Bob Eva. How old is Eva? 22 years old. 25, 24, okay. Am I right? The model before? Correct? Before like that? After? Okay, let's just say my drawing.
The age difference is 22 years. So the arrow part should
What's that? What is that? Oh, 22. Oh, sorry, I think 22, isn't it? The age difference must be what? 13 years old, isn't it?
No, the age difference is 22. So which means Ava is 13.
Oh, age difference. Oh, sorry, I make a mistake. Oh, sorry. Sorry. I thought it was 22 years old. This is ridiculous. Okay, sorry. 22 years old, am I right? 13, sorry, yes, my mistake. Thank you. Am I right? That's a bit, huh? Now, after many years, okay, after many years, this is after, I draw the blue one, let me say the blue one. After. Now, let me copy down this one first, okay? This is before, this is after. Bob, Eva. I can draw the same one, by the way. I may draw the same one. Wait, so high, I cannot. Sorry. What was here? This before, right? After a period of time, I don't know how long that is. I'll draw it on the, remember I told you I have to draw on this side? I don't know how long that is. Okay, it's unknown. But I know one thing. What's the difference? They're twice as old, am I right? Where do you draw the twice as old? The twice as old, I must cut here. How I know I will cut here? That's one important information. I hope that you remember the information. Age difference never change over the years. If you are 5 years older than your sister or your brother, the 5 difference is always there after 10 years when it's the same. Am I right to say that? That is important. That's why I know I can just cut like that. Something never change. Now, one thing about mathematics, there's something that never change. Like in this case, age difference will never change. So once I do that, then straight away, I will know that this part is what? 22. Am I right to say that? Now I know that this is 13. Am I right? Answer falls out nicely. You see the thought process? That's I want to show you how to, so somebody to learn how to think through it. So I use a concept that age never change. I use a technique to draw my unknown on the left-hand side. It's easy for me to make the comparison. Are you with me? I tell you what, instead of going on to all these numbers, they say, well, my goodness, this number is hard to understand, all these numbers. Right? Let's do something with not numbers. It's a little game. Right here. Now, I want you to do this little one. This one take 1. I'll tell you what to do. Okay, now, okay. I want you to put the thinking cap, okay? This is about numbers. It's A, B, C, D, all right? So no numbers here, so there's no calculation. Okay, it's a very simple job. You see there are points here. I want you to connect the points. A to A, B to B, C to C, and D to D. And the line you draw, of course, can be crooked line, doesn't matter. Of course, it's a crooked line, okay? The only thing is that these lines cannot cross each other. No crossing. Fair enough, number one. Number two, you cannot draw outside the big circle. All must be within the circle, and all connecting lines cannot cross each other. These are only two requirements. Now, think about that. You can use a pencil slightly to draw it and see, can you do it? I will give you two so that at least if you make a mistake, you can change it and then you can draw another one, okay? And if you want more paper, I still have more. Okay, now. I still have a few more pages here. Now, okay, how to connect the points? A to A, B to B, C to C, D to D. And you think about it. How you want to connect them? Okay, anyone who succeeded in drawing, what just show me? Joining A to A, B to B, where's the B? B to B, C to C, D to D. Okay, they're all here. You got it? Great. Alfred did it. Come, show the class. So she did it. She's the first one to do it. Fast. Okay, now good. Now you put it here. Wait. I'll give you a red pen to draw it.
I have other colors there.
No.
Other colors there.
Colors one? Okay. Okay, she did it. Oh, she's fast. Okay, good. Yep. Great. Easy? That's what she did. Okay, you can go ahead and let the student try out. You'll be surprised they can do it very fast, the kids, sometimes. Yes, they can do it very fast. What's the time now? Okay, let me just take a look at which one you want to try. Tell me. 2, 3, 4. Just try one more. Any of you want to try one of those? You let me know. Which one you choose? 2, 3, or 4? Which question that you want to do? Come on. Number 4. Okay, number 4 exactly is from our dear PSLE, Singapore, our primary school leaving examination. It's a national examination administered to all the primary 6 students or the grade 6 students before they go to secondary school. Okay? Okay, good. Let's do number 4. Okay, try number 4 and see what happens. Okay, any taker? Let's take it here, and this is how's it? This is our PSLE. This one is quite similar to the one that you saw in the video there. Try to put back, going backwards. Then you can figure it out. After the ratio, this is after, right? It's a 1, 2, 3, the red and the blue. The red and the blue. This after. Which is small. The ratio of the red to the blue is a 1 to 3. Am I right? After. I just draw the border first. I don't even look at the question. You don't look at the question when you don't have the bar model there. But what can I do over here? What happened to the blue? Is it 40% what? You use it already, right? Use up 40%. So that means these are the left. This is what? 60%. Correct. 60%. That's one of the things there. And he used up also how many red? 45. Am I right? 45. This is a red one, 45. This one used up already, right? Use up, just cross it out. Use up, cross out. 45. So that is basically, I see that. Huh? Now, and you look at it. So I have the after. Then what can you do? Look at it before. Now, before must be what? Must be this long bar, am I right? Before must be this long bar. So must be this together with this. And before, this is 60%, am I right? But I first time is 100%, am I right? So there must be two more. Because it was 20, so you can say 20, 20, 20%. Am I right to say that? So you get all together in the 1, 2, 3, 4, so 100% here. So that's before. So I use this one to construct my before. Am I right to say that? And now I know one thing. Once I put it back, I have a total of how many? Two what? 285, am I right? And I know that this is 45, am I right to say that? The answer just comes out nicely. Am I right to say that? Are you with me? Yes. You see the way the bar model sometimes can be quite creative. You go behind, you go backward. This is the only place I can. This is the only place I know the ratio. That's all I know. I got no choice. I use this one to go back. And once I go back, oh, that's easy already. The way I go back, I can count. How many units here? Now, 1 unit, 6 units here is equal to what? 258 minus 45. Am I right? I got 1 unit. What's it? One unit, I know this already. Everything is out already. And once everything is out, finding fraction is easy. Am I right?
How do we know that the rate before rate, right? The blank plus 45 equals to 2 parts?
No. Wait. I never said it's equal to 2 parts. This is only a number. It said that because if you read the question here, okay, where is it? It's not 45. This is a whole number though. So I just I put up. I never said this is not 2 parts. This part is not the same as this part. This is not one. This is only a part of. Yeah, we know how big is this part, but I know they are not the same. In other words, you follow me? They are not the same. Yes, you get it? I just draw it here. It can be longer. It doesn't really matter. All I know that this one with the red and this one are not the same thing. That's why I call units. It's only about 1, 2, 3, 4, 5, 6 units. I never call this to be 1 unit, never, because I don't know what that is. But I know one thing, since the units are all the same, so that means this must be equal, this one. So therefore, the rest must be what? So that's how I would want to do it. Am I right? So that's how you see it. You follow me? Yeah. This is not 1 unit. Don't count this. This is not 1 unit. By the way. So that's a kind of a PSLV question. And I think once they get the bottom done up, they can answer these 2 questions easily already. Straight away, they will get it out. Is it too challenging for the kids? Okay. I give you this fresh from the oven. It's only last year's October. Our kids in Singapore face this problem. What problem? In the 2022 PSLE paper 2. And you read it. Okay. Now they are now playing with no more bits. Now they're playing with the magnets. Okay, so for the magnets now. This is about large and small magnets. Now look at it. You want to try and see what's this? You got large and small magnets at the beginning. Altogether, 97 pieces of magnets. It's not there. Have figure out this one? Not yet. How's it? No? I don't know. I don't know what you do. Have you got it? No, not yet. Okay, I tell you what, this one, all right, never mind, don't worry if you don't get it. I'll show you the solution, but I'll show you about the thought process, how to think through this question. Not so much looking at the solution, okay? I want to look at it, but I want to share with you what's the thought process in this one here. Now, when you talk about, again, it's pretty much the same as before. You always give you two different items, but the total number of them, that's it. You don't know how many is which, you know. You have both the big and small manex, and the total is 97. Then it says something about he gave away some of the manex. He gave away 4 small ones, was given out. And then, but the thing is that Tina bought some more big manex. So he gave away some, and then he'll buy something more, but the big one, the big one. So that's what happened. Now, so as a result, what happened? The number of the large manex increased by 50%. So in other words, the number of manex that Tina has at the beginning never changed. That number never changed. In fact, he gets more. That means what? He's getting more is what? He bought what? Half the amount of what she already had. Am I right? That's half the amount. So that's one thing that he gets. Half the amount that he has had. Okay? And now, the total number is what? 114. So the number of manex has increased from 97 to 114. This is the total, all the manex, big and small, all together. So that is the concept. Now, how to draw this bar model? That's the question. Let me explain about the bar model. Before like that, all agreed? Simple. Now, you don't ask me which bar should be longer or shorter. Really, I don't know. You never say, whether I have more small one or the last one. I can simply draw, and that's all I'm doing. So the kids want to draw the small one to be a shorter bar, a longer bar. It's okay because I don't know what that is. I mean, there's no basis which bar should be longer. I just arbitrarily pick. Okay, I say, maybe a small one. The reason why I look at this one, maybe that's the way it is. Like, so be it. It doesn't really matter. Now, but what happened is the after. Something is very interesting. This is the last one. Look at the last one. He bought some more, right? Half of this amount, right? So I'm going to take this bar and take half of it. I add on to here, 50%. This one's supposed to be like this, am I right? Can't wait for shorter bar. I shorten it. It's probably gray out. I mean the same size, but I just to say this one is being given away. So that's how I will draw the bar model. So this part is still small, this is still large. So as I say, how is it like? It doesn't really matter. You don't worry about whether this is a bit longer or shorter, makes no difference at all. You follow me? Now, once I do that, I know that, he said that now he has what? 114 after. Am I right? 114. Okay, so that is the before and after model. You follow me? So that is the thought process. And then how you would draw the model. You can take the before one and you just multiply from there. A lot easier. Like the one earlier you pack the thing on the left-hand side, it's the same thing also. So these are kind of a way to draw the different types of bar model. Okay, and to share with you, that's basically what it is. Now, once I have done that, then how many large manex does Tina have? Now, that means you got so many, right? How many? Is that quite easy already? You look at these two. If I take this minus this, what is going to happen? Because this is a bigger number, right? So I can find the difference of these two. Once I find the difference of these two, what happened then now? I'll put it down there first. After giving away 4 small magnets, this one given away, it said that total number of magnets must be 93. Am I right? Total number. A bit lesser now. Okay, so that, in other words, this must be what? 93. Am I right? 93 is over here. Watch out, huh? The number of large magnets must be what? Must be therefore 114 minus 93. Am I right? 114 minus 93. It must be this little piece here. Am I right? 114 is from here to here. 93 minus 93 here, number of magnets after giving away. This is the original though. Am I right? This one is given away. So this must be 93. Am I right to say that? So the difference of this and 93 must be this one here. Now I know. If this is 50%, it's 93, right? This is twice of this one, right? So the number of large magnets, what? Board must be this. Okay, sorry. There's some more here. Sorry. So at the end, the number of large magnets is how many? 63. Am I right to say that? You got it? So this is part A. How many large magnets did Tina have at the end? 63. Because I know that this is 21. So 21, 3 of them. So 21 times 3, you get it. Or 42 plus 21, same thing, whatever that is. You decide what's the best way to handle it then. All right. So, okay. So that's basically the part. Now, part B, by the way. Did Tina have more small or large magnets at first? How many more? Now, at the beginning. Beginning, he has how many? 42. Am I right? The small one is what? 97 minus 42. 55. So actually, at the beginning, there are more small magnets. Am I right? So there are more small magnets at the beginning. How many more? 13 more. So that's how it is like, this kind of question. And that was last year's PSLE question to our dear kids. You see, the whole thing is about the thought process, how they think. The whole idea about learning mathematics is learning how to think, as I said before, at the beginning. It's not just a memorized formula, no, learn to think. And once the kids learn to think and become an habitual thinker, they learn a lot better in other subjects also, to be very honest with you. Actually, learning requires thinking, I put it this way. If learning without thinking, then we become like a machine, very robotic. So I hope that by now, the whole focus about learning mathematics is learning how to think, learning how to apply strategies. Now, that one, of course, I said it will be in March. I will have this one, problem-solving strategies. This is another part of it, It's basically in problem solving, the students applying both thinking skills as well as problem-solving strategies. These are not the same thing. They are two different things altogether, but you use it together. So that's basically the crux of it. Okay, so much about the bar model. I've covered all the 3 types. And then my last part here is how to teach our dear kids bar model. Okay? How to teach them that they know what we are talking about, this whole idea. Okay, now we are not talking about for ourselves now, we are thinking for the little ones. Pedagogy, how you teach. So this is a question here, how you teach, not what you know. What you know is, now you know everything, but how you teach the little one, that's the issue which I'm talking about, okay? If you want to teach them using the bar model, you need to take a structured approach. The word is a structured approach. To help them visualize mathematical relationships. That is the key point. It must be a structured approach. Can it be anyhow? We try here and there, you know. So that must be very structured. There's a structure. If you look at just now the way I'm doing it, you can see there's a systematic handling in the problem solving there. All right, how I apply the thought process. I will make it even clearer later on then, okay? Now, the key idea of bar model is to break down complex problems into what? Simpler and more manageable chunks of information. For what purpose? To identify relationships among them. That's the whole idea. In bar model, students must learn how to identify relationships among the different objects, different quantities. Whether it's in fraction, whether it's in ratio, percentage, anything, how they're related to each other. And therefore, your job is to demonstrate to the kids the structured approach step by step. No shortcut, to be very honest. And they must learn it from young. Actually, once they learn this structured approach there, it will also benefit them when they go to grade 7 onwards, secondary mathematics. Because this approach is quite useful, okay? Now, let's go to the approach here. The first one, understand the problem. Many a times, our kids don't quite understand the problem. For many reasons. Number one, those with language problem, of course, they read it, they still don't understand because they don't understand the words there, you know, but language usage, fair enough, that's number one. But for those who understand the question, they are so impatient, they want to solve it immediately also. I know already, I want to solve it. They never pay attention to the little details. They just want to jump right into the solution. Am I right? There's another issue with students, though. They're very impatient. So therefore, if you want to teach them a bar model, before even they draw the bar model, I say that, they must understand the problem thoroughly. Not skim through and then, I understand it. No way. They must understand thoroughly. So, first of all, read it carefully, you know, at least twice. So you read once, you may miss out. You read it twice. Now, identify what the key information there. That's important. Huh? What is given them? The known one, or I know something. Or what needs to be found? The unknown. I got the third one. What's implied? You don't give me, but I can imply. What do you have? So there's some hidden information there also. I can imply. Once I do, I will just jot it down. Even the question never stated, I just put it down, okay? So this is the kind of thing there. Now, for those having a word problem there, learn to highlight or underline keywords like altogether, left, how many left, more, less, all these important words, fewer, whatever that is. Highlight them slowly, okay? Another thing, if you want to know whether to answer the question there, ask them to reason the problem in their own words. Tell me what they know. Tell me in your own words. Once you tell you in your own words, then you know what is missing in what they're saying. That's important. So, these are the ways to help them to understand a problem. Now, let's look at this question here. Excuse me. Marcus has $24. Carl has 4 times as much money as Marcus. Ken has $18 less than Carl. How much money did they have altogether? No. Very short question. Understand the problem. Pick all the keywords. Right? I highlight all these keywords. How many people here? 3 persons. I have the name. Oh, I have a Marcus, I have a Carl, and 3 persons there. Keywords is what? $24. This is what I know the number. 4 times as much as. All right? Ken what? $18. So these are the keywords. All together, I know. So once they do that, they can make a brief note, wherever that is, by the side. Just a brief note. 3 people. Marcus, $24. Carl, 4 times Marcus' money. Ken, $80 less than Carl. Total, don't know. You see that? Just juggle somewhere on a piece of paper. Then that's called out. Now you see what happened? They break down the question very carefully, pick up all the key words, key ideas, and just in their own way. Of course, I'm writing in this way, they may write in a different way. It's okay, it doesn't matter. The important thing is that they must be able to pick up all those, key words, key ideas from the words. Now, once they have that, of course, then they can start drawing the bar model. Fair enough. The next step is to draw the bar model. All right. In other words, they will have to translate the words now, the information from the word there, into a visual representation. Now, they'll decide whether it's a part whole, comparison model, or before-after model. Oh, by the way, these terms are never used in the classroom. Do you know that? You don't really teach them. They will use it. We compare these two, for example. That's all. Some of the kids may not be aware of the part whole model or these terms. But if you want to show them, tell them, it's fine. But you are not required to tell them, this is a part whole model, this is a comparison model, this is an additive comparison. I mean, they get very confused by all this terminology here. This is a before-after, okay? But what they want is to get a concept. If I see something has happened, I will draw a model before something happened. I draw a model before something happened. And that's called the before-after model. That's all I had to know, period. So terminology is not important that we are using now, okay? So they will know what kind of model that they were supposed to draw. Then, once they got the bar model drawn up, they must put the labels there. That's important. If you put the label there, it's totally, you put the label there, something like this. Put some labels there. So now after they've done that, we'll set up the bar model. Okay, now from what I have, I draw the bar model. You see that? Based on these notes I've taken, I just draw here. So that's step 2. So this is what the kid's supposed to do in this way, you see, step by step. All right? Now, once they're done, so far I still have not solved it yet. I just draw the bar model first. Up to this stage, I still have not thought about solving it yet. So the kids shouldn't rush, I must solve it now. No. You do it in this way. Draw the bar model first. Okay. Now once you draw the bar model, the next step is what? Solve the problem there. Of course, what else? They solve the problem there. Okay. So now that's where they have to formulate those equations, or we call it number sentence, if you want to call that. That's why we write lots of number sentences. All right. So based on the bar model, they have to decide what kind of arithmetic operations supposed to use to add, subtract, multiply, or divide or anything. They were supposed to do it. Then, of course, they will solve it. That means they do all the calculation. And then, of course, they will double check the answers. Fair enough? So this is the third step. Now, that's where they really execute the solution. Okay? And you can see actually the solution is very short. Usually, in bar model, the solution is very short. It's about just a few lines. It's not that many lines if you look at it. Why? Because most of the information is captured in the picture there already. That's why you can see they draw very few lines. That reminds me about a few lines. I was doing this primary math about the bar model in Kazakhstan. You know what's Kazakhstan? It's Central Asia. It's north is Russia. The right-hand side is China. Okay, so Xinjiang, that side. So it's a Muslim country, by the way. Okay, and the dressing looks very much like Mongolian because they were formerly conquered by the Mongols. So therefore, I was there and teaching them. And then, by the way, they had not learned Singapore math. The math is quite high level, to be honest with you, because all the teachers there were trained in this Soviet mathematics, or Russia today. It's a Russian mathematics. Russian has a very high standard in mathematics, same as China, Russia, but what is missing is the pedagogy, the way you teach the kids. And that's what I learned from Singapore. Because the way they teach the kids is the same as the good old ways that we all have gone through in our good old days. Teacher come and tell the student from A to Z, for the whole period, the kids just copy, they learn by heart, and that's how they learn it. And so they discovered that kids actually have lost interest. They just memorize it. So when I first went up there, and they looked upon me, say from Singapore, and of course, Kazakhstan, I don't know how many times bigger than Singapore. Singapore is just a small little dot that you can't even see on the map. Kazakhstan is a big country, very big, even bigger than Malaysia, by the way. So in a way, I can sense and say, who are you coming from a country which I can't find in the map to teach us how to teach mathematics? Honestly speaking, and I don't blame them. So when I stand before them, there were about 30 of them, by the way, there are lots of them, and they look upon me with some suspicion. Are you sure you can teach us anything? Who are you? Fair enough, I don't blame them. So for the first 3 days, we are very courteous with one another. We talk, but I can see that they are very much guided. Oh, our math is so high and mighty. Who are you to tell us about teaching mathematics? So on the third day, we had a word problem, and I put a word problem on the board here. Oh, by the way, these people, they don't understand English. Russian, yes. So what happens, I got a translator, take my problem and translate in Russian and put it in the whiteboard. So there are two whiteboards. One is in English, I use a whiteboard. One is a Russian, is for them. So the question has been translated and put on the board there. So I said, okay, fine. I said, I invite one of you to come forward and to solve this problem in your own way. Oh, they're very sporting. Okay, come up, one, they come up, and they come up here. So start doing it. Spend, I don't know, about 10 minutes, the board full, filled with X, Y, Z, whatever they call that. They're good with algebra, by the way, very good with algebra, first class. And I look at them. Okay, so they finish it, answer. Okay, good, well done. My turn. I stand in here. I start drawing a simple bar model. I did the problem in 4 lines. It's a big contrast. There's a board full of numbers, equations flying everywhere. My only 4 lines, something like this. They're stunned. How can this board full thing can be summarized into 4 little lines? But one thing about them, I must comment, they're very observant. There's one lady teacher make a statement to me. You have lots of thoughts given in the picture. I said, yes. Because before I solved it, I thought through the whole problem and I tried to conceptualize all this information, key points, all the things, into the picture. It speaks for itself. You see that? Because the way they do it is say, let X be a Carl's number, a Ken must be X minus 18. They will do all kinds of funny things, line by line. This is algebra, right? So they'll do it in that manner, So that's why I feel the board full of equations there. Add, subtract, multiply, you just name it. But you think the poor kid, wow, so difficult, must have been board full, solve a prime problem. I said, there's 4 lines there. And they were really surprised. Only from that point onwards, they listened to me carefully. There are 4 lines, little lines there. They see the big contrasts, And I was there for about 10 days, And after that, they're very good. They say, hey, please stay on. Ask me to stay on. I said, sorry, I must fly back home. So these are the kind of things, people must understand. It's a thinking process. It's not just learned by heart. Okay. By the way, this coming Saturday, I have one workshop, problem solving strategy for secondary math teachers. Same method, I'll tell them. Teach the kids to learn how to think, not to memorize, as well for secondary mathematics. I'll learn how to think, that's the whole idea. Key points, finding relationship is the same old way. What I'm telling you in the primary level, same for secondary level, except the content, of course, is higher, fair enough. And this one, there's no difference there. So you can see that, how this problem is being done as such. Okay, now, the third part is one. Now, don't forget the last part. Kids never want to look back. I finish, happily give it to the teacher. I'm done. Right or wrong? I don't care. Your job. You tell me whether right or wrong. Am I right? So sorry. Please be patient. Look back. It's important for students to reflect on the process, what they have done. That's important. All right? Spend some time, ask the student to explain how the bar model represents. Tell them, you see, just like what you're doing now. Okay, tell me, how do you think about it? Show your thought process. That's important. That's how students are supposed to learn, you see. How the bar model helps them to find the answer. Then tell you verbally. That's, that's in the teaching process. And you can practice a similar problem, give them something similar, change the context, but everything remains the same, by the way. So that's important. Same way of doing it, but change context. Another one, of course, you can generalize it to extend it even further. Now, I show you how to give a similar problem to solve and how to generalize it, okay? The next 2 slides. Now, same question, how do I say? First of all, similar problems first. If you look at this one, it's the same as that one there. It's the same thing. Am I right? But I change the context. See whether they can still do it or not. That's important. Now, that's one of the things I would do. Or I can give them something like this. Totally different. Context, but similar. Because once you do it that way, that means they learn the bar model which they have. It's not only for that question alone. The same reasoning process can be applied to a similar question as such. You see that? That is important. So they're starting to memorize. Just, oh, I know that this line of thinking is good. It's a thought process. Right? I can just use it over and over. I just change the label, change everything. It's fine. Change the number. It's fine. So that's how it's supposed to be done. Okay? Now, or I can generalize it. Now, this one, basically, you want to what? Give it to the smart Alex. This I want to be challenged. Okay, you can do this one. I challenge you to be something else. Now I have what? I got 3 bags, A, B, and C. At first it's 2, right? Now I have 3. See how they will handle it. You extend it further, or something like that. Even you can put in the fractions for that very method there. Okay? So these are to challenge the smarter kids based on what they have learned. In fact, this is one which eventually I will use it in my what we call the differentiated instruction. Something is coming eventually to Eduseeds, the differentiated instruction. You heard about this term here? We call that the DI, differentiated instruction. Let's share with you very briefly what this term means. Differentiated instruction. What it simply means is that, in a class, of course, if you have only 5 students there, maybe those you still need to differentiate because you have some smarter ones, some are slower ones. Am I right? Let's have 10 students there, but some are very good, some not too sure, some are damn smart. So what happens if you have these 3 flavors in the class? Then how you handle it? You differentiate your instruction. That's important. So you have to decide how to teach these 3, So some of the things here, it can be used like this one. I can use this one for those very smart ones because they finish the work already when the rest is struggling very hard. But they feel bored. Teacher already know, I finished already. What should I do? Okay, you want to do? There you go, my friend. You do it. Challenge them a little bit. They like to be challenged. These kids, they like to be challenged. They can challenge them for that very matter. So that's how you can keep them busy all the time. Together, what? If you see, you cannot slow down just to help the slower one. Then the rest will feel very bored. Oh, I know already, but you spend a lot of time with it. So you have to decide how to handle these 3. So that's the whole idea about this differential instruction, is to help you to be able to deal with students coming with different abilities, with different interests. You follow me? Anyway, but not for this workshop. It's only on the bar model. Okay. Next time, I think when I want this one, then you will come for it. Then you know what I'm talking about for the differentiated instruction. Okay. So these are some of the teaching tips for you people just to ponder upon. Start with simple problem. It's always good to start with something simple. Very simple. Basic arithmetic like addition, subtraction. before to something more complex. That's important, okay? Yeah. Use guided practice. They do, but you guide. Now I'm doing it, you do, I will guide you for something like that. You guide them as they do it, as they will do it, okay? And they can work through as a whole class, as a class, before allowing to work on their own. So after that, of course, it will be what? Incorporate what? Hands-on activities. It's good to have hands-on. Except for the younger one. Grade 1, grade 2, if you take the younger one, hands-on is a very good, hands is a good learning tool, by the way. Give them counters, pebbles to play with, and they will do that. Make comparison more or less or whatever. So hands-on is a good way of learning, okay? So, you know, they can do that. Blocks, strips of papers, you can do that, represent bars, you know, before they go to drawing. That's one of the things there. So they can play with it first, then they draw the bar model. And the important thing is to promote consistency, consistent use. Draw the bar model. Don't skip it. Ask them when they first learn it for all the word problems. Make it become a habit. That's important, okay? They say, sir, I know how to solve it already. Yes, but please do. Draw it first. You want to skip it when it comes to exam time, because of time constraint, you want to skip it, I can solve it, be my guest. It's okay. But when they are learning, please practice drawing. Because if you don't practice, what happens? When they come to questions they can't solve, they say, okay, you draw a bar model. I don't know how to draw a bar model to tell you that. I think that's quite sad. Because they never practice drawing it, so of course, after a while, they forgot how to draw the bar model, you see. So that's the key idea. Promote consistency in the use of the bar model. So these are some of the taking points which I'm going to share with you. All right? So, and one thing to your teachers, don't think algebra, think visually. That's a key word. If you think algebra before you do the bar model there, it's very painful, it's very difficult, to be quite honest with you. When I draw a bar model, I never think algebra. In all honesty, no algebra comes to my mind. Oh, by the way, when I say that, I'm telling you, my specialty is algebra. And I'll tell you, don't think algebra at this stage. Serious, you know, so. Well, I hope that you learned something today. I finished a bit earlier, isn't it? Did I? What's the time now? 3:30, good, okay, a bit earlier. 2:30, yeah. All right, so, Sue, you want to get Martha to come up? Martha? Yeah, she will come up. Mother will come out to have a closing. So anyway, so today, I hope that you have enough or not enough. What say you? You find something useful, informative? Yeah, okay. But the key thing, as I said before, you know, not so much that you know how you deliver to the kids. That is a key idea. It's always a challenge to teachers. Even for I myself, I've done with the young kids before, you know, and many a time they do surprise me in the sense that the way they look at things, the way they think, is quite different from the way we think. I used to conduct an enrichment program for primary school kids. And that's one I have activity-based learning. Very cute, you know. I mean, this is after class about 1:30. Then, you know, they all come to my session there. Then it's okay, fine, you know, today. And then they come to my class. They say, oh, it's like tuition class. I said, no. They said, you're coming to play games, huh? Play games. Then the spark, play games, you know. It's like, okay, something new here. But this game requires some thinking. Oh, okay, they know my thinking, you know, can play with friends, you know. So I let them play. And they get, surprisingly, you know, once they come to the game, they get very excited. That's one of the trouble. You got to really manage the whole class. I think it's about 40 of them, you know. It can be very noisy when they play. At one time, they were so noisy, you know what happened? The principal office is downstairs, you know. Then they come up and come to my room there and say, hey, what happened to the kids? How come they're so noisy? Oh, I said, I tell you what, the principal, they get very excited. Look at it. I said, what are they doing? Oh, they're playing games. What games? It's a math game. Oh, okay, they will go down. What's a math game? They will go down. Very cute, you know. And they learn it, you know, and then they play with it. And I think it's about, I don't know how long, about an hour and a half, or something like that. It's not that long. So it's okay, today, okay, that's the end of it. They say, no more, finish already. They ask me, you know. I say it's too short. They want to play some more, you know, very cute. These are the grade 4 students, they want to play some more, you know. So later on, I got some feedback from them, you know. But one kid, they're very honest with me, it's a girl, it's a student. It's a girl, and she stand up to tell me that I used to hate math. Now I hate the beats. Good improvement, I said. You had the beats only now, okay? Come on. That's exactly from their fear, from their hatred for math, whatever there, you try to reduce the fear factor, reduce the hatred for math. Hopefully, there'll be some improvement among the kids. So hopefully this bar model will alleviate their fear for solving word problems there, but start something simple, as I said that. Okay? All right, now. Martha, you want to close it? Yes. Okay. Now, with you.
Okay, you guys made it. you guys lasted. So how was it? Informational, helpful, motivate you to motivate your students with the bar models. I hope so. So can we just thank Dr. Lai? Okay, so I think with this we can end. Thank you to our online participants too. Yeah, okay, so before we end, I have your certs here. So we won't make it so official, but I will just leave it on the table so you all can take it. Okay? So, okay, good job. Thank you.